stuff about cryonics, but Merkle trees are great, and Doges are also great. Raft Merkle and Doges are not actually connected. The only connection is that I like both of them. So what are Merkle trees, right? A Merkle tree is like this data structure that lets you create one small object that commits to a large number of objects, where it becomes very easy to prove for any one of those objects that that object is inside of this big entire tree, right? So you have this one object that's called a header, and it might be committing to like a million different things. And for any one of those million things, you can make a short proof that shows that that one thing actually is in the set of things that's been committed to. Why do we care about this? Well, Ethereum blocks are big. The Ethereum state is even bigger, right? The Ethereum state is like 40 gigabytes. So what if you want to prove something that happened in a block or prove something about your account, and you want to prove it to someone that has these block headers that are at the top, but that does not have the entire 40 gigabytes or the entire, really huge amount of data in the Ethereum chain? Well, Merkle proofs come to the rescue, right? Basically, you just provide the value, you provide a couple of like sister hashes going up along the tree, and anyone can verify the proof by just kind of continuing to hash up the values going up together, and then seeing whether the root they get matches, right? So, really powerful technology. Ethereum actually, uses it everywhere. Last fun thing, layer 2 protocols, right? So most people, or increasingly more and more people don't use Ethereum directly. They use what are called layer 2 protocols that inherit security from Ethereum and add higher scalability on top, right? So rollups, I wrote an article on them. They're really fun. There's a bunch of them. From a user's point of view, living on a modern layer 2 feels like living on Ethereum. Applications work the same way. But because these applications don't stick everything on Ethereum directly, fees are many times lower. So layer 2s are great. Layer 2s are how Ethereum is scaling. And encourage everyone to pay attention and learn a lot about layer 2s this year. So finally, future directions. The merge, done, yay! Okay, next stop, the search. Increasing scalability, finally going sustainably below 5 cents a transaction, getting us to thousands of transactions a second. Next step, the Verge, replacing Merkle trees with more efficient structures that let Ethereum nodes be much lighter. Ethereum nodes don't have to have huge amounts of data, it becomes much easier for anyone to run them. Yay! The Purge, clearing out old data, clearing out technical debt, making Ethereum nodes easier to run, and making the Ethereum protocol simpler. Woohoo! And the Splurge, grab bag of various useful stuff. Account abstraction. EVM improvements. Proposer builder separation. Making everything amazing with ZK snarks. Yay, Ethereum's getting better and I'll have to keep rewriting this presentation for next year. Amazing. Thank you guys. Bye-bye.
Huge round of applause for Vitalik. Engraving. Oh wait, Vitalik, I need that clicker. Vitalik, you have the clicker? Awesome, super, thank you. Okay, so we are coming to a close of the opening ceremony, but before I close it, before we finish, I would like to give you all a quick orientation to Devcon, to what to expect over the next 4 days, and maybe some things that we've done differently this year. I guess when you give a team 3 years to plan an event, they start to get creative and start to think a little bit differently. And we've learned a lot from past events that we've done, past Devcons, and really have tried to make this one better. And so a couple things that we've done. We've also tried to hear a lot of input and feedback from the community. So roughly 2 years ago, we launched the DIP process, which is the Devcon Improvement Proposal Process, mirrored after the famous Ethereum Improvement Proposal Process, which is named after many other similar improvement proposal processes. The gist of this is basically we want to hear feedback from you all, and we have heard a lot of feedback from you all. And so we're super excited to have a lot of different community integrations in this year's Devcon that we hope you all enjoy. One of those to highlight is the community hubs on the first floor. This year we have 6 different community hubs, interest groups from around the Ethereum ecosystem who have their own dedicated space. So be sure to pass through there and talk to them. Everything from a woman leaders hub to a temporary anonymous zone to a ZK hub, regen, and more. We also have in the basement, the hacker basement. It's a little hidden, so let's see if you can find it, but I promise, it will be worth it if you do. Feel free to head down there and co-work and chill, even into the evening hours, because Devcon this year is open until 11 p.m. each night. For the first time in Devcon history, we're not kicking you out at 5 p.m. sharp. We're open until 11 p.m. to continue fostering community collaboration and fun and things like that. So, and we're not just leaving the venue open, we're also facilitating and encouraging community activities. So we've built a Shiva chill out, we're calling it, in the back of the venue, basically with a live stage where we'll have live music from fellow Ethereum musicians performing throughout the day and particularly in the evenings alongside our happy hour from 4 to 6. So now you have an additional option to stay around, to hang out, to collaborate, and to check out different art experiences that will be happening also in the Hacker Basement and the Shiva Chill Out, alongside a special ETH LATAM community hub. If you're from Latin America and you want to meet your fellow community members, head to the Shiva Chill Out on the first floor to meet them. And I'll also mention a fun DIP, actually, something that was proposed by the community, is a treasure hunt. So I was told to basically mention this sticker as part of the treasure hunt and to leave the rest up to you. This team has been working on this for months to make this treasure hunt cool and interactive, and they've been here in the venue for the last week or so trying to make it fun. So good luck in that treasure hunt. And lastly, I will say this year, we hope you really enjoy the programming. We've had the most applications we've ever received at 1,300 plus applications for speakers, for talks, for workshops. We only had room for roughly 300 of them, and so we really had to be selective. And so hopefully the content that you see here is of the highest quality and accessible and available for all. So we wanted to have talks that were not just high level, only for experts, but also for beginners and for intermediates. So do check out the mobile app that we also created just for Devcon to find the talks that you would like to attend. And I'd like to welcome you to what is officially now the biggest Devcon ever by a factor of 2. And to mention that this is just the start, not just of Devcon, not just of this week, but we're still early. This is the start of Ethereum. We have a lot to go, and a lot to do, and a lot to build, and good luck. Thank you all.
Okay, yeah. Just
We're still like 15 minutes from starting 12:30.
right, and you've got all my slides all.
Hola, hola. There you go. Thank you, Steve. We made it. So we are with the full room today. Sorry, it's been long days for the Devcon team. Happy to have you here. So I will be fast. We have Steve. He's going to talk about alternatives to liquidity staking. So is this talk is going to have questions, or you're going to run 25 minutes?
I'm going to run, hopefully, to get some questions in at the end, but I'm fully aware we're coming up to lunchtime, so
Okay.
so people might want to ask you questions over lunch.
Perfect. So
Okay, thank you very much.
welcome.
Hi, yeah, my name is Steve Berryman, and I'm from Attestant. Attestant is an Ethereum-only staking company. And what we're going to look at today is an alternative to liquid staking. Liquid staking has been phenomenally successful. And as with anything in the Ethereum ecosystem, something that becomes that successful becomes centralized and then becomes an issue. So we at Attestant, and been talking to some other staking companies, try to come up with some other ideas around how to transfer validators from one owner to another without going through the exit queue. So really, this is one idea that we've been floating around, and we are looking for other staking companies to be part of this, building this out if we think it's a successful direction. Okay. Where do I need to point this at? Yep. It's this box, is it? Okay. So what is staking? So I've kept this quite light. In the way I want to go with this is to really give the justification for what we're trying to do, and the detail and getting into the weeds. Really, I think if you're interested, come and speak to us, and we can sort of talk through some of the detail. But it's really the rationale why we're doing this. So let's have some context around what is staking in the first place. What is staking in Ethereum? So, sorry. Okay, I'll keep talking. This is a very high level. Clearly, there's a lot of complication goes underneath the hood of this for Ethereum staking. But from a very high level in how we want to view this is we're locking up funds, 32 ETH. You send 32 ETH to the deposit contract. This started in December 2020. You sent your 32 ETH to the contract, and that basically gave you a ticket onto the Beacon chain, and that ticket enables you to build a validator and go through a certain number of steps and duties, and if you carried out them duties, you receive rewards. So some of the things you receive rewards for are testing. That's you're doing that every 6 minutes. It's the bulk of the rewards you receive, and if you're online and you're testing, you get a very small amount. Anybody that's used the blockchain website and has got a validator will see their rewards keep chipping in. And proposing a block. Doesn't happen very often now. There's 7,200 blocks a day. There are 44,000 validators out there, so roughly every 62 days you'll get a block. But they were the only two places to get rewards back in December 2020. Then we had the Altair fork, and that introduced sync committees. Sync committees are even rarer than blocks. Block proposals, you'll get one of these, I think maybe now once every 3 years. But when they do turn up, you make a lot of money during that period. It's only for 2 days, so if you're offline then 2 days, it's unfortunate. And then, of course, what we've seen with the merge. The merge, and this is really, everyone's excited, because now we're not only getting transaction fees, which used to go to the miners, but now we can spend it, and we couldn't spend before. So this, is exciting for the first time after almost 2 years of having money locked up. Finally, we've got some we can spend. And of course, MEV comes in here as well. So that's staking in a nutshell, Ethereum. If I can get this to work. Okay, liquid staking. So briefly what liquid staking is, and it's hard really not to really not mention Lido, because Lido's the biggest player clearly, and there's going to be tried to be other players, but again, it's another centralising force. So what is liquid staking, and why do people go for this approach? Well, currently over 30% of the staking rewards go to Lido, and that's not great. But then again, Lido runs under different node operators, so it's not quite as centralised as you may feel, but still, you know, it's an ecosystem, we want lots of various different options. But why has this become so popular? Well, however easy, you know, some of us techies think it is to run a node, it's just not easy. And there are lots of complications, and you have to keep the thing updated. And, you know, a number of people I speak to go, well, it stopped working. Well, you know, you're just not committed enough in what's going on in the community. So it's difficult. It's difficult to stay on top of things. And so with that, people are going to want an easier solution to pick up some rewards. And of course, you've got slashing. I mean, you mention slashing to somebody and they go, that's it, I'm not even going to touch home staking. But being in the staking company, we always try to get people to stake at home. But I mean, you know, the technologies for most people is probably out of reach, and they've got to want to do it. So when, you know, Lido came along, it's just it's convenient, it's so simple. You just go and buy their token. You go and take your ETH, you go and buy some token. You've got two choices. You can go and mint it directly, or you can go and buy them on an exchange, Uniswap, and basically you're there. That's it. You stick it into cold storage. You forget about it. Lido uses a rebase token, so your rewards go straight to your wallet. There's no messing about. Costs you 10%, but you haven't got to set up a box and you haven't got to worry about it. So and it's been, you know, a phenomenal big success. But what's the downside to it? Well, one of the downsides is you lose control of your Ether. However good Lido are, you are handing it over. You're handing over your Ether to a pool of Ether, and you're getting effectively an IOU. Now, for individual small investors, less of an issue. For large institutions, this is a no-no. It won't get past the compliance department. There's also some other issues which are very interesting, regulatory issues. You're in a pool, the pool gets tainted with Tornado Cash, it comes tricky. So people don't want to necessarily, large institutions don't want to be involved in a pool system. And of course there is a tax thing. In some jurisdictions, going from one token to another can be seen as a disposal and a taxable event. So that is something that I think probably a lot of Lido users probably don't realise that many jurisdictions put that as a taxable event. Okay, so what is an alternative approach? Now we've been throwing this idea around for a while, but the thing is you know, there was this little thing called the merge that sort of kept us busy for a while. But now that we're sort of over that, and you know, it is, I think Danny said, you know, it was uneventful, which was for a staking company, that's what you want, uneventful. So now some of these things come back on the radar, and also they do require some extra changes to the EVM in order for some of this stuff to work. But our idea is that we make validators transferable so that they can change ownership. Now, when I say transferable, I'm not talking changing staking company. The validator will stay with the same staking company, but you can transfer the ownership to somebody else. And at the moment, the way validators work, you have a validator key, and that's the thing you have online to create your rewards, and you have a withdrawal key. The withdrawal key is just a regular Ethereum, or in fact, it can be an Ethereum 1 address, or it can be a BLS address. But once we get past to the withdrawals, so I didn't mean to go past, and get to withdrawals, this thing doesn't have to be just a withdrawal key. It can actually be a smart contract. And we've already got a smart contract that handles this sort of thing very well, NFTs. So we could use an NFT smart contract which issues a receipt to the validator. And now the validator is transferable. It can be moved around. And it's also an NFT that's actually valued something. It's not, you know, it's not a JPEG underneath. It has actually got 32 ETH under it. So this idea, once we create this smart contract, then we've got a lot more flexibility. And in one way, it's not up to us to decide what the market does with this. It's just quite interesting to put. The great thing with DeFi, you put stuff out there and see what happens. But I've got a couple of my own use cases where I think this would be particularly useful. For example, you've got a large institution wants to buy 1,000 validators, and somebody wants to sell 1,000 validators. Now, you can offboard it. It takes at least 15 to 24 hours if there's no queue, and then somebody else onboards. It's quite heavy on the network as well for Ethereum to do that. And also, both sides are losing accrued interest. So if you think of this as a bond, you're losing money for the 24 hours, and if there's a queue, it could be a lot longer. So wouldn't it be more convenient if there was a marketplace where two people just bought the validators off each other? There's instant settlement. The Ethereum network handles it extremely well. It's just a transfer. We've still got the same validators running. It just becomes a much easier way of large institutions to be able to buy and sell. I mean, clearly the marketplace has got to have liquidity to do this, but you could imagine you're just about to get rid of 1,000 validators, you would go to the marketplace first. If there's a liquidity, you're going to get a better price, or you're likely to get a better price than just unwinding it, because you're going to lose a day's worth of interest and rewards. Some other stuff you could do with a receipt, and I don't know if this is an advantage or disadvantage, I'll let you decide, but it could be used as collateral in DeFi. So all them wonderful things. And the great thing with this, it comes with a revenue stream. So anybody who's into financial engineering could come up with many different views of ways this could be used. And it could be very interesting. And I think a marketplace where buyers and sellers can come together, I think would be very interesting. And as I say, it's for the network, for the Ethereum network, it's also better not having these huge amounts of ether coming in and out of the system. And why wouldn't this be the better way of transferring and providing liquidity to staking assets without going through the on and off boarding? Okay, so what are the benefits? I mean, the biggest one is you still own the ether. It is a receipt. You still own it. It's yours. It's not pooled. Okay, so it means decentralization because people are not pooling this thing into Lido or into another pooling system. So, and the other thing with this is something as a staking company we think about. If you're a good staking company in Lido or you're a bad staking company, nobody cares because all the rewards are just mixed. With this, we start to find out who are the better ones because the marketplace can monitor it. The marketplace can look at all the stats for all the different validators. And clearly, we think that's a good idea. And it's something that also, if you think of these things as starting to look very much like bonds, credit spread could actually be, these are like credit spreads. So the staking companies become credit spreads. And I think that would be quite an interesting marketplace. I think this is also the vanilla vision we've got, but I could imagine we could take a step further on a lot of this stuff, and we could build insurance, we could build fees, we could be a lot more, because now it's a smart contract, so everything's up for grabs, really. So why hasn't this already been done? The obvious question. Can't do it, or we can't do it easily. We can't do it easily. The biggest problem is that we've had the merge, and so what's the problem? These two things are now talk to each other, but they don't. They don't. We did the minimum to get the merge over the line. And so at the moment, the EVM can't talk to the beacon chain. So we've got no way of being able to test the state and test you actually own that validator. So there is actually an EIP which is aiming for Shanghai, which is the 4788. And what this does is produces an opcode for the EVM which allows you to see the beacon route, the state route. And what does this able to do? You can build a Merkle proof and you can prove the validator's yours, and then you build the NFT. So it just needs this little bit of glue, and then we're away. And hopefully this will get included into that Shanghai, and we will be testing some ideas around this. Yeah, so really that's the main thing of this not being done is just we're waiting for the next thing for this EIP to come through. Hopefully in the next in the next round of updates. Right, potential issues. There's always going to be some. It's the same thing as the advantages. It can be used in DeFi, and we've seen the good and bad of that. So just be wary of it. And we could have bugs. It's a smart contract. We've seen a few of them as well in the last few years. I think with the bugs thing though, this stuff is using the standard technology. We're using an NFT contract. We're not putting any innovation in new stuff. We are gluing it together differently. So clearly, lots of audit around that. But we're not going out and building some new smart contract. We're using technology that we've all been using for the 2 or 3 years. Right, and that is the end of my talk. As I say, it was quite lightweight to give you a rationale of why we're looking into this. If people want to get into the weeds, please come and contact me. We're looking for getting more staking companies involved. This thing only really works if other staking companies. It's a network effect. If it's just a testant, it's not going to work. So clearly we need other people involved to build the tools out to make this. If the community thinks something like this is an alternative, and even if it takes a small percentage from people using Lido, that's going to help the decentralization. And I think I've...
Thank you, Steve. We have 4 or 5 minutes more, so maybe a question from the audience. So here.
Thanks for the presentation. So you mentioned that the liquid staking tokens are subject to a tax. Here we are also receiving a receipt. That receipt will include some yield, right, for staking rewards. So I think it's the same disadvantage here, correct?
You mean from the tax point of view?
Right.
So could be. I mean, it does depend on jurisdiction because you could argue, and I'm not know much about tax, but you could argue that a receipt is different from a token transfer. All you're doing is like a receipt for goods. I know the UK government doesn't do that, so I know you're right in that fact, but there is a lot of debate going on about it. But really, there has not been a transfer of assets. So that would be the thing I would like tax authorities to look at, to go, look, you've just got a receipt. You still own these assets.
Right.
But you're right in that it's messy. It's a messy field.
And as for the collateral, I mean, that sounds messy, right? Because collateralizing NFTs, I mean, NFTs are non-fungible by definition.
Yeah.
So, using NFT as a collateral for a DeFi?
I mean, it is already done. So, and I'm not suggesting this is a good idea. It's already done. We've seen there are many platforms already doing this, and it's not for us to try and decide where the market takes this stuff. It's just the point that you can use it for collateral, and I'm sure somebody will do that. So,
right. Thanks.
Yeah.
Hi. Thanks for the talk. It was great.
Oh, sorry.
Yeah. This might be a silly question, but I'm going to take the chance to embarrass myself. So validators, don't they run with hardware? Is that a thing? So how are you then going to kind of transfer the hardware with the NFT?
Right. So I didn't go too much into that, but it is a good question because there's a certain assumption I'd made in the presentation. This would be done by staking companies. Okay, so we, as in Teston, we would still be running it. So it's not transferring from the point of a staking company. So if you've got a validator, you're still, and it's with us, you're staking with a Teston, you're just selling it to somebody else. So, and a Teston is still doing its job, so it doesn't stay. I mean, a validator is basically made up of 2 keys. A validator key, which is what a Teston hold, and then the withdrawal key, which the client holds. So, all you're really doing is changing the ownership, but what we're not doing is changing the people that are doing the validating.
Thank you.
Have you all thought about what this looks like with shared operators inside of the NFTs? So it's not just one staking company, but it's a collection of people running together.
I've not really, I've personally not really thought about that. We've kept it very simple in a way of, providing some liquidity to clients who would need it. This is where this has really come from. And, it's just a way of taking the pressure off the network that, it seems silly to me that we've got a lot of validators coming in and a lot of validators leaving. And really it's one big organisation wants to buy it and another big organisation wants to buy it. So it seems a natural way to do this. I mean, there are also some other things that, like, you may, one institution may have all their staking with one company and another institution has all their staking with another company. And I could imagine for risk management, they may actually swap some of their validators over to split the risk. So, I'm sort of making up use cases, but it's the sort of thing that once you've got a marketplace, then and it's liquid enough, I think people would probably use that sort of facility.
All right, thank you so much, Steve.
I think there was another.
Yeah.
There was another question here.
Sí.
That's the last one. Just like very brief.
So you mentioned Lido. I'm curious if you think there are ways to synergize with existing like pooled staking derivative projects, or if you have any thoughts in that direction.
I mean, definitely. We talk a lot with Lido. I mean, we write a software stack called Vouch, if any of you are familiar with. But Vouch, 22% of the Lido operators use Vouch. So there is constant communication and with these guys. Whether they will get involved in certain things, but certainly Lido don't want to be 40% of the network, I can tell you that. So it's in their interest to have options that work to spread the load. So, we talk to them about various different things, so they will certainly be in the conversation. You could do. Again, I think let the market decide, all right? Because, would it make sense to do many things with this stuff? I think being able to transfer ownership is the big use case for my thinking. But I can imagine there'd be lots of funky products built off the back of it. So I was somebody involved. Thank you.
Thank you so much. Thank you, Steve.
Thank you very much. Thank you. Right. That's all right. That's a bit quicker than I thought. I know. Yeah. Yeah, I do know you, yeah. So, yeah. How do I get rid of it?
But I wanted to show you something I made in 2020.
Let me get rid of the mic first.
Yeah, you doing?
Master of Chaos.
Thank you. Did you manage to get some? Oh no. Next time let us know, we can save you some. Okay, at least something. I know they told me to point it this way, but I guess it's not right now, but in general it should work. And sorry, in terms of timing, it's pretty much 25 minutes.
Okay.
And that's fine, right? That is okay, perfect. Sorry. I think like the thingy to hold the microphone just popped. Is this? I think this just popped a little up. This is fine, yeah? It's not too far up. Yeah, no, don't worry. It doesn't hurt. All good, no problem.
Maybe right here, like this.
Perfect. Oh.
Oops. Oops. Some hair.
No worries.
It's coming out.
Thank you very
Like
much.
this?
Perfect. This seems perfect. Thank you very much.
Let's check that you can change this practice, that you can go move forward.
Yeah. Perfect. Excellent. I think I smile a lot, so I'm worried that this is gonna go off, but it.
No problem.
Yeah. Okay.
Did you sponsor eFlower with a bounty?
Yeah. We had 3 winners. It was super nice. There was 3 really cool teams that built on top of us. That was cool.
How was the level of the hackathon for you? I mean, you were having like
Actually, pretty good. Like we were in Denver before, and then we didn't have a single good submission, and now we had 7 submissions, and 3 were really good. So I was super happy about it.
also like the swag that you got, like this like jumpers.
Yeah, the jackets, yeah. Yeah, it was good. No, it was super nice. Like over a very good experience.
Is this your first time in Colombia from this
No, I have been here before. I used to live in Panama for a little bit, and then I took like extended weekend trips to Colombia. I was in Bogotá, Medellin, and Cartagena.
Acquires fragility, collapses, and then you're back in
Yeah, exactly. But Bogotá is nice.
hypercomplexity. This is the picture on which it evolves.
Cool. Yeah, it's super great, right? So many, like 5,000 people or so they came, you know. Very big, very exciting. Have you been to any of the other DevCons?
Complexity without these, there is no alternative bottlenecks. And my belief is that you cannot.
Yeah. Oh, cool.
But can we at least reshape crisis pathways? So I went from green but not quite red, so orange pathway. I think of this as equivalent to the question, can you do the equivalent of Asimovian cycle history?
Oh, that's awesome.
And my belief is, yeah, maybe you can do it.
Yeah. Yeah, we have a few Spanish speakers on our team. Like, we should send them like one time to like be. Oh, what is this? Can you move that?
And maybe because of that, you benefit by getting a period where hypercomplexity can grow, right? And examples are Y2K, the crisis that turned out not to be, the Montreal Protocol for ozone that worked pretty well. It's sort of like backsliding now, and ozone is back in the problem. Sometimes self-disruptions seem to work like Netflix moving from,
All right, so.
the merge, I think I would still put a question mark on it. Hit the category of this definition.
Buenas tardes. Hello, everyone. So this is our second talk. We have Anna George. I think she has the best tagline that I've seen on the agenda. Anna is the master of chaos, CEO of Chaos, and she's going to talk about one block, one batch. Please put the slides.
But you're still alive. That's
There you go.
Ooh. Hi everyone, thank you for being here. So I should have put MEV in my talk title because we are actually talking about MEV and I think we would have a higher attendance. But anyways, it's gonna be an interesting talk, I promise. Cool. So yeah, the focus for today is how basically application design decisions can remove or at least reduce the centralizing force that MEV is placing on the Ethereum blockchain. All right, so let's see. Basically, the first part of the talk will focus about how, or the degree of centralization in proof of stake. So basically, we will look at a few data points telling us how decentralized are we actually today. And then the second part will focus on a more bright layout for Ethereum, where we are heading, and hopefully, ways of how we can avoid the dystopian future scenario. And that will lead us to the next part, where we will talk about how specifically we can make design choices for applications to reduce MEV, and then dive into core protocol as one implementation of batch auctions that basically facilitate this. Cool, let's dive right in and look at some data. So we had the talk right before was focusing on validators. And like he was saying actually, is that the set of validators today is quite centralized in a way. You have staking providers such as Lido, who hold more than 25% of the market share, followed by individual stakers, but then already you have the centralized exchanges, Coinbase, Kraken, and Binance, who in total combined also make up more than 25% of the entire validator set on Ethereum today. So you can say we have already some degree of centralization in Ethereum today, but of course, now with MEV, you add additional risk of decentralization growing further, right? Like MEV, why is that helping why is MEV causing centralization is because people or like validators that have the chance of proposing the next block, they can move transactions around in a way that they're able to extract additional value out of it. In this way, they're actually able to reap more rewards from the blocks than anyone else would be able to do. And this way, they grow their pie more and more over time. And this is already bad. This already existed in proof of work, but now in proof of stake, this is accelerated because now you also have the downside, basically, that you know in advance who are the next set of validators, so you can have more sophisticated MEV attacks that involve multiple blocks and even are taking place across multiple blockchains. The response to that is PBS, the proposer builder separation, where basically you now divide the tasks of the validator into two. You have the block proposer and the block builder. And now the block builder is basically competing against each other, and the one that is able to extract most value is winning the competition because they are basically bidding against each other, and the one who is able to pay the most to the validator is the one who's picked. So you might say that basically now PBS is helpful to move the responsibility, like to move the centralization away from the validators to the block builders. But now actually this is problematic because now you have more centralizing force on the block builders. You can even enter a scenario where basically more than 60% or even more than 90% of all blocks are created by one single block builder. And this can even be accelerated if they, for example, would have access to private order flow. So if now you would have a wallet such as MetaMask who decides I'm doing my transactions to a single block builder, then the single block builder would have additional advantages over the other block builders and would more reliably be able to win this block builder competition and gain more and more share of the network. Okay, now let's actually get to the interesting point and look at some data. So here you see basically how much MEV has been extracted, 145,000 blocks before the merge and after the merge. And this is roughly equal to 20.1 days. And basically, I mean, proof of stake has only been live for not even 4 weeks at this point. And if you look at this data, it almost looks like we are extracting less MEV right now than we did before the merge. It's interesting, right? But what is the conclusion? Why is this the case? Now, if we look at this slide, we basically zoom into one specific kind of MEV. sandwich attacks. And we can look basically that it's showing the first 20 days of sandwich attacks on proof of stake. And you can see basically that the amount of value extracted via this attack is growing, right? So basically, at the beginning, when we moved from proof of work of proof of stake, we had one short period of time where less MEV was extracted, but now over time, we are getting back to the same stage as we did before. And now here, what we see here is basically a chart that is showing the adoption of MEV-Boost. And MEV-Boost is the protocol created by the Flashbots team that allows for this proposer-builder separation, that allows for this block builder competition. And the interesting part is that basically they correlate, right? Like you see how with the growing adoption of MEV-Boost, you also have growing extraction of sandwich attacks. So that's one important point to make. But then also let's see how the adoption is going. So at today, already more than 49% of all validators that we were looking at in the first slide, they have already integrated MEV-Boost. Now let's go one level further and look actually at the relays themselves. So MEV-Boost was created by the Flashbots team, but it's open source, so anyone can create their own relayer with their own rules of the game for the competition. However, the relayer that was created by the Flashbots team is by far the most leading one, right? It has 83% market share. So you would say, what's the problem with that? What's the problem about Flashbots having a large market share? But the problem arises then when one of these relayers decides to start censoring transactions. And this is exactly what Flashbot does today, right? They are complying with OFAC, with the Office of Foreign Asset Control. And this means that any transactions that were created by the accounts that have previously interacted with Tornado Cash are not being put into these blocks. So if Flashbots has 83% market share of 50% market share, basically, of those that are being integrated by validators. This means that today, already more than 40% of all blocks on Ethereum are censoring transactions. They're censoring the accounts that have previously interacted with Tornado Cash. Now, we zoom one level further and look at the block builders. So who is actually behind these block builders? And here you see basically, this is an entire overview of all the block builders today operating with any of the relayers in PBS. And you see that the top two have more than 50% market share. That means if basically you have 50% adoption of MEV-Boost, and within MEV-Boost, 50% of blocks are created by two players, that in total, of all the existing blocks that are today created in Ethereum, 25% of them are created by two single individual block builders. And then just adding again the argument that I'd mentioned at the beginning, basically if you have private order flow, if Musk or anyone else is deciding to sell their order flow to this one individual block builder, you have very fast and accelerated centralization force even more, like you have these block builders will win even more market share. And suddenly this dystopian future scenario of where Ethereum hopefully is not heading towards suddenly doesn't seem so unlikely anymore. Already today you have two block builders having 25% market share, and they can easily grow this very quickly. Okay, that was like the negative side of the talk. Let's now focus more on like the hopefully more utopian future where we are heading in Ethereum. And for this, let's have a look at a quote that Vitalik said earlier this year. So what is his vision for Ethereum, right? Like how can you avoid the centralizing force of MEV? And what he is saying is that we have to create an installation layer around the core protocol to basically ensure that these negative externalities that are created by MEV cannot affect the core decisions that we are taking. Because right now, with having smart contracts built on top of Ethereum, you have these applications that now allow suddenly for decentralized exchange trading and for liquidations and all these transactions. They basically set incentives now for value extraction that give more power to very important players and stakeholders of the Ethereum network. And we need to find a way to not do this, because right now our solution is basically, okay, damn, validators are centralized, so let's move it to the block builders. But now the block builders are centralizing, so where do we move this? And we need to find a way to avoid this. We have to have a better structured way of protecting the Ethereum core protocol. And what Vitalik said himself is basically, the way forward is that these risks, they need to be absorbed elsewhere. They need to be absorbed either by layer 2s or by the applications themselves. Here we have another quote by Stefan, the co-founder of Flashbots, who actually last week announced that he's leaving the team because he does not agree with the censoring that Flashbots is doing today. And he is also stressing the point that the right way of dealing with MEV is not to basically try to extract it and then sell it or like distribute it, but the right way is to create applications that don't extract the value in the first place. And this leads us basically to the next part of the talk, where we will look at how can we design applications in this way that they're not exposing MEV. To do that, we first have to understand where MEV is actually coming from, right? Like why do we have this? We need to understand where it's coming from in order to be able to avoid it. We basically believe, or it's pretty clear actually, that one of the reasons, or like the main reason why MEV exists today, is that within a single Ethereum block, you have multiple different token prices for a single individual asset. So if you use the example of decentralized trading, for example, yeah, you can have a block where 5 people all want to sell USDC, for example. They all interact with the same AMM, but each of them would get a different price within a single block that has one single time. Like it's very interesting, right? Like you have an AMM, one person interacts with it, they move the price, the next person interacts with it, they move the price again. And because of that, they basically create incentives for other players to jump in, move their transactions around, place additional transactions in front and after them to extract value from these users. To give a more concrete example of a real block, this is like 6 days old. We had one single block where there was 11 different traders that all traded ETH USDT. And ETH USDT is obviously a super liquid pair, right? It's like one of the most liquid pairs on Ethereum. And still, within a single block, you had 8 different clearing prices. Yeah? Like the price spread across 1,337 USD to 1,351. So you had more than 1% spread in price within a single Ethereum block. And this very much demonstrates like the value that can be extracted if you have so many different prices in one single block. Here, this is just like a nice pointer, because MEV obviously has been discussed for a very long time. It hasn't been addressed for a very long time, but it was known about since 2014. This is a Reddit post, and the interesting part here is basically the screenshot on the right, where Vitalik interacted with, and he basically said, well, one way of how we could tackle this problem of value extraction is by processing orders in batches. So let's take a look. If, like, looking back at the previous block that we just saw, where we had 11 different traders who got 8 different clearing prices, what would happen if we were able to batch them all together and would give them a single unique clearing price? Then we would actually be able to even offer them better prices, because we wouldn't have to move the price on a price curve up and down, up and down. But we would also be able to not have this much price impact and have additional value that we could give back to the users. And in this concrete example, it would be $930 that we could additionally pay out to the users. But the real benefit on top of this is that because you have a single clearing price, you don't expose those trades to MEV. Okay, and this leads us now to Cow Protocol, which is basically an implementation of batch auctions on Ethereum today. How does Cow Protocol work? So we are doing batch auctions, we are batching trades together. And what happens is that basically users on CowSwap or Cow Protocol, they go to our UI and then they sign messages. They sign an intent to trade. And this is actually really important, right? Like, because they sign a message and they don't just execute, they don't just sign a transaction on Ethereum. This gives us more flexibility what to do with these transactions. We are actually then able to match them together. So we collect all these orders in our off-chain order book, and then we have a competition. We have a competition of so-called cow batch builders that basically look at what are all the transactions that currently exist in our off-chain order book and try to find the best possible way of matching them together by finding a unique clearing price for all these trades. And then the winning cow batch builder is the one that would settle these trades on-chain. And what is to be highlighted here is that it looks maybe on high level, it looks very similar to the block builder competition, but it's very different. It's quite the opposite, actually, because in the block builder competition, you are really you're focused on extracting most value from the transactions, right, in order to be able to win the competition against the other block builders. But on CowSwap, you maximize the value for the users, the block builder, the batch builder that is able to find the best possible prices for our users is the one that would win the competition. And this is enforced by the objective function that we are using, the batch builder that is maximizing most the utility for the users is the one that wins the competition. All right, so how does this work? How do we keep our cow batch builders honest? Is they participate by staking on our protocol, then they can participate in the competition, and in case of malicious behavior, they would be slashed. But if they actually win the competition and they execute the trade on chain, they're being rewarded by the protocol. So now this is all sounds very good in theory, right? Let's look at it in practice. So Cow Protocol has been live since a year and a half. We have been processing $15 billion in trading volume, so we have a lot of real life examples. This is like an example batch from 11 days ago, where we had one user that was wanting to sell $40,000 worth of Manifold against USDC, and another user that wanted to actually buy Manifold, wanted to buy $48,000 worth of Manifold. So in this particular batch, our cow batch builders were able to match the two trades together, and in this way, create additional surplus for our users, additional value that could be given back to the users. Because instead of processing $48,000 worth of tokens on one AMM and shifting the price, and then settling another transaction of $40,000, $48,000 and moving the price back, instead we were able to match these two trades directly against each other, and only the leftover amount of roughly $8,000 needed to be placed and executed in an on-chain AMM. And this way, we were able, due to the price impact, the removed price impact, we were able to save $1,500 for users, and also we were able to save on protocol fees for the users, an additional $800 that didn't have to be paid to the AMM. Cool. And that basically leads me already to the final slide of my talk. So our vision is to protect the users, and our vision is to protect the Ethereum core protocol against the negative centralizing externalities of MEV. But to achieve this, we really have to become the backbone of decentralized trading on Ethereum. And for this, what we would like to achieve is that really our cow batch builders are submitting one batch for each Ethereum block. Ideally, this batch would actually be placed first in the block, because this way we could also avoid negative slippage and failed transactions. But the real argument here that I want to make is that even if our batch is not placed first in a block, by growing our share, we are basically reducing the total amount of MEV transactions in a block. And this means, in other words, growing the share of cow protocol means at the same time reducing the share of MEV. Thank you, everyone, for watching the talk.
Thank you, Anna. We still have 5 minutes more, so if there are questions, I got 1, 2.
Hi, I have one question. How
Yes.
it can be more profitable when MEV? So you have to reward more than flash bots, right?
Do you mean, can you repeat your question? You mean how can we ensure that
How you can give more rewards to Cove builders than MEV builders?
So we basically, maybe can I go back in my slides just to make this point clear? Is that possible? So okay, otherwise I can explain it. But basically we had this one slide where you could see that the value chain of a transaction from it's being placed and it's being executed on chain. So basically, here. Okay, so what we do, so these are two separate processes, right? Like the first part is basically cow protocol, that is the application on top. And what we do is we collect the user orders and we collect them, they're signing intents to trade, so we collect them off-chain in an off-chain order book. And then we have the cow builder competition, and they have their own set, they have their own rule set and their own competition rules, right? And that it is completely separate from the block builder competition. So someone who is participating in a cow batch builder competition, they know if they participate, they only get rewarded, they only win if they're maximizing value for the user. But this is orthogonal to the block builder competition on Ethereum. That happens at a later stage. So right, like the cow batch builders, they find the perfect solution. They then submit them on chain, and on chain they can actually decide how they want to submit this. This is up to the batch builders. They can either submit them directly to the public mempool, or they can submit them via a relayer if they decide that they want to additionally protect themselves against MEV. However, basically at this point in the execution, if they're being front-end or sandwiched, this is actually something that the block builders, the batch builders have to pay for. So at this point, the user is already protected by the price that the cow batch builder promised. So the cow batch builder wins the competition by promising I can get at least this price, and then they're held accountable for this. So this is for sure the price that the user gets.
Hey, thank you for laying out the problem with L1 right now in terms of MEV. Very nice slides. I'm curious about how you, moving this problem into the application layer, how you deal with censorship resistance problems in the off-chain order books specifically. So today, if I go to the CowSwap website and I make a transaction, like how do I know I'm not going to be censored by the CowSwap like company or whoever runs this protocol?
Yes, no, that's a very good question. It's basically something that we're working on. We still have some centralizing components in Cow protocol, but essentially, basically, this is right now we have this off-chain order book that is hosted by us, but the idea is that in the future this will be decentralized and not hosted by us anymore. And yeah, but basically this is the answer. It's like it's an ongoing process where we have to decentralize more and more of the components.
One last question here, and
question is, when you're trying to remove the MEV in the blocks by cutting these batch builders in between, how is it then still attractive from a builder perspective, since he has less MEV in the block now? How can he still win the bid auction? And then how you make sure that the block gets actually proposed?
So, I mean, right now, usually not 100% of the transactions in a block are MEV transaction, right? So basically, you would, even if you're not the first in the block, you could still ensure that you're part of it. But I think one interesting point that where we could get at is by the more order flow we are actually processing, the more surplus we are generating, right? Like this was the point on like this one slide over here where we have this like real example of creating an additional $2,300 in surplus. So what we could do is, for example, if we are creating this much more value for users, we could take a percentage cut of this if it was needed in the future to pay block builders to guarantee execution in a block, we could do this. But our future scenario is more focusing in the direction that hopefully this won't even be necessary, right? Because we are basically trying to win over more share of the general transactions on Ethereum, and then that would automatically reduce the amount of MEV transactions in a block.
Thank you, Anna. We are running out of time, so you have enough time to go to the next talk. Thank you so much, and a big round of applause for Anna.
Yeah, Anna, this is for you.
Oh, thank you very much. Yeah.
So the optimal solution would be to have every transaction in a batch auction. So
Yes.
you have one price per block.
Yeah, exactly.
So could that have negative externalities for liquidity providers?
Because they would get less fees over
Yeah.
time. Yes, that is an argument, but I think a few answers to this. So I think in general AMMs are super inefficient, right? Like you need to store a lot of value on chain, and that in itself is yes. Oh yeah.
And you can talk
Yeah.
outside.
Sorry.
No problem. Let me help you out. Sorry if I. Oh. There you go. Oh, I don't want to. There you go. welcome everyone. We have plenty of room, so you can come inside. We are going to start in 2 minutes. All right, buenas tardes. We have Dr. Klaus Kursave. Sorry if I'm pronouncing that well or not. Okay, Kursave is like German last name? Okay, he works for the Vega protocol and is going to talk about beyond staking. Big round of applause, please.
One, two, three, test, test. Yeah.
Again.
Okay. So let's try this again. So I'm working on introducing diversity on the blockchain layer, and the end goal would be to change Ethereum, but also other blockchains themselves to enforce diversity on that level. As said, I'm working for the Vega protocol. That's a derivative trading platform that works on its own blockchain. If you want to know what exactly Vega does, there's a wonderful workshop tomorrow where you can spend 1.5 hours playing with it. I'm talking about the lower level, so I'm doing blockchain research, MEV, fairness, and yes, diversity. In our case, Tendermint, but it's an approach that works everywhere and should also work on Ethereum, and that's the goal, to have a discussion with Ethereum developers. How far can we drive this to put diversity onto the blockchain? So generally, why do we need validator policies? In the old days when Bitcoin started, we had this beautiful anarchic cyberpunk point of view that we have millions of validators in their dorm rooms securing Bitcoin. That used to work, but now validating is a serious business, and that has caused dependencies, that has caused centralization factors. So some of the basic assumptions we had are wrong, and Anna has just shown there's some very few validators that own an enormous amount of the Ethereum share, so it's not really that decentralized anymore. So there's a couple of policies and some other work that I also would like to advertise as people actually thinking about a structural way to figure out what actually do we want from validators. The bad thing is if you start with the same axioms, you may end up somewhere totally differently, so this still needs a lot of debate. But one thing that I think nobody needs to debate anymore is we need more diversity, and centralization or an undiverse system is a very bad idea. And if we don't have enough examples, so from other blockchains, Bitcoin at some point had a vast majority of the mining capacity in China. So if China had not said, you guys use too much energy, get out, if they just said, get out and leave your rigs here, then China would now own Bitcoin. Pretty bad idea. Ethereum has a similar problem that there's not so much validation power in America, that the United States has essentially said Ethereum is now a US citizen, so we have legislation over you, so congratulations Ethereum, you're now a citizen of the United States. We had other diversity problems. Early Ethereum testnet, 75% of the validators had client code. There was a bug in there, the whole thing stopped. Solana, almost 30% of all validators run in the same Amazon cloud. So if Amazon goes down, then so does Solana. That's not really diversity. And if you go all the way back in history, Leslie Lamport, who actually invented the term Byzantine agreement, already said the whole threshold model just doesn't make sense. That's not what I meant when I said Byzantine. So we're even using his term in a totally different way than it was originally intended by assuming failure independence. So we need to assume failures happen dependently, states fail, implementations fail, flashbots may fail or behave in a bad way. So we need definitely more diversity on the chain. One controversy in there, and that's a discussion that pretty much always comes up when talking about this topic, how about enforceability? So if I say I want geographic diversity, a validator can just lie about where they are. And that's true, they can use a VPN, so I can be in China and claim I'm in the US, no problem there. So there's a couple of things. So A, just because I can't 100% enforce a policy doesn't mean I shouldn't have it. I have door locks at home, I have friends who can pick those door locks, but that doesn't mean I remove my locks and put my valuables on the street. They still serve a purpose, even though they're just 95% secure. And if we create a business case that at least honest people create diversity and dishonest people at least have some risk and need to show some criminal behavior to violate diversity, then we have something. It's not perfect, but just giving up because we say somebody can lie about where they are, that doesn't really help. And there's some really fun research on finding out where you really are, even if you're in a VPN, and you probably, if you ask Netflix or Amazon, they're also pretty good at that. So it's a discussion that needs to be had, but my opinion is, even if we cannot 100% be sure about what a validator says, who they are, what codes they run, where they are, that doesn't mean we should just go home and say, well, then we all end up in China, fine, and we can just stop the whole thing. The way we normally do this, or the first idea to implement policies, is by economy. So Ethereum is very heavy on slashing. If you misbehave, we may slash you, so you better be a nice validator. We can have positive incentives like a diversity award. If you run your validator from New Zealand, we give you more money. Or something indirect like a delegated proof of stake. If you add diversity to the network, you're a good citizen, more people stake to you, you get more money, everybody is happy. That has a couple of problems. My favorite one being MEV. I mean, you have to mention MEV here. With MEV, we don't know what the business model of the validator is anymore. They don't make money by fees, they make money by MEV extraction. So paying them a diversity bonus is like paying police a small bonus in a country where they live generally of bribes. That's not their business model to get their salary. Their business model is getting bribed, so economic incentives may not really work. We have fun financial instruments where I can outsource flashing risks. And if it's just economics, then I have a higher incentive to cheat. So it's one approach. It definitely is one error in our toolkit, but it's not the end solution. So that's why we want to implement diversity on the consensus protocol itself. And to get there, I need a little bit background on consensus protocols. And there you see how old I am, because these is papers from 1984, so the impossibility results probably predate everybody in this room, or almost everybody. And the worst one is it's actually bugging the whole community since 40 years by now. It's called Fisher-Lynch-Patterson, and they proved that consensus is actually impossible. The end, let's all go home. What they more precisely proved is no deterministic asynchronous protocol can guarantee termination even if one validator may crash. And this is a result we've been working around for the last 40 years. So this is the reason why every consensus protocol is a bit messy, because if it were easy, we would run into an impossibility result. There's others, you can actually write papers with 1,000 impossibility results in the area, which are a very fun read, but that's actually the most fundamental one. Now, of course, we can cheat. We have cheated. That is why we're all here. The first way to cheat is it says asynchronous. So if you use a timing assumption, you can get around it. This is what Tendermint is doing, for example. The bad thing is if you guess your timing assumption wrong, then bad things happen. You get very inefficient. The second one is probabilistic. It says deterministic protocol. So that's actually my favorite approach. We just terminate with probability 1, which is generally good enough. And then I don't need a timing assumption. Or what was invented by Bitcoin essentially and is now also partially used by Ethereum. Why terminate in the first place? If I have a longest chain protocol, I just run it. At some point it's good enough, but technically you never really terminate. Now after the merge you do, but technically a longest chain protocol never finalizes. You always could theoretically roll back your transaction. So this is the 3 ways we got around this. That gets us to the consensus map. So we have essentially 3 approaches. We have the randomized approach, the partial synchronous approach, and the longest chain approach. And they all have nice properties. So the both committee-based ones are finalizing, which is great. Different timing assumptions. Their disadvantage is they don't scale as well as the longest chain protocol. Every validator there needs to talk to everybody. So if I try to run those protocols with 40,000 validators, everything will explode. So this is why people still use longest chain. Now the reason why I'm actually going to all of this, the technique I'm now talking about is actually very well explored for the 2 committee-based protocols. We know exactly how it works there. For longest chain protocols, like the old Ethereum, Bitcoin, Solana, we sort of can make it work, but we probably need some more statistical evaluation to be sure what we're doing. And for Gasper, well, we need to talk because Gasper is a pretty complex beast. It works there. I'm just not sure nothing explodes if you would implement it. So this is where it would be a very good idea to actually have a small discussion. So what we want to do is call generally adversary structures. So normally, as you saw in these protocols, you have thresholds like only 1/3 of the validators may be corrupt, or in longest chain, half of them. And we want to get rid of this. So forget about thresholds, they're boring. What we want to do is write down explicitly all coalitions of adversaries I want to be able to tolerate if they are corrupt simultaneously. So I could say I want to tolerate if 1/4 of all stake plus an entire country goes corrupt, independently on how many validators are in this country. And for now, I just write down these sets and say this is the sets I want to tolerate. It's a pretty flexible notion. We can later scale it down to make it more manageable. Then we want to modify the protocols to work with this. And unfortunately, we also have some requirements. We can't just say I want to tolerate everybody going bad. So there's some limits what we can do in there. And if we look at the committee-based protocols, or also the Casper part of Ethereum, you usually find somewhere in the code something like wait for 2t+1 or 2f+1 votes. So this is where the thresholds come in. And in pretty much every modern protocol, there's exactly 3 thresholds they use. It's n-t for n validators and up to t traitors, 2t+1 and t+1. If you now go back in the protocol and if they say t+1, what do they actually mean with this? What do they want from this property? We have 3 things we need. We have a threshold where if I talk to that many validators, I know at least one is honest. Honest majority, or this is the longest I can wait before I can't wait anymore because everybody else may be corrupted. So this way we now can replace the thresholds with actually sets. So the t+1 is replaced by any set on my list of people I want to be corrupted, plus 1 more guy. And for the committee-based protocols, we can just essentially take the thresholds out of the protocol, replace it with our set properties, and we have pretty much automatically transformed that protocol into a more flexible model. We can do the same for the proofs, although it's probably a good idea to manually check the proof afterwards. But we can generically take a protocol that is threshold-based and go to set-based version, which is then much, much more flexible, which allows us to explicitly write down, I want to tolerate all of these people going bad. And there's some limits. So the limit we need for committee-based protocol, we used to have a third of the validators can be bad. Now it's 3 of the sets I write down must not cover the whole set of validators. So if I say I have 3 countries and I want one of them to be able to corrupt it, doesn't work. If I say I have 4 countries and I want to tolerate if one entire country goes down, that works. So that's our limits. On the sets, it's necessary and sufficient. So we know if I satisfy this condition, I can still solve consensus. If I doesn't, it's impossible. So this is how we can compute what are the sets we actually can generate. How do we define actually who we want to tolerate to be corrupted? Longest chain protocols are slightly different. They don't have a threshold. The thing we have here is a leader selection algorithm and a longest chain rule. So what we can do here is change the definition of what a longest chain is. So if I have, say, consecutive blocks generated in America, I can say the length of each block goes down in the longest chain depending on the number of blocks that were generated in the same set before. So first block generated by an American validator has length 1. Second block generated by an American validator has length 0.95. Third block is going down 0.8 something. So the more blocks are generated by validators in the same corruption set, or say in the same country in this case, the shorter they get. So at some point, just anybody coming from another country will be longer because they just can't add to the chain anymore. So we can use this approach to also secure a longest chain protocol and have these corruption sets on a longest chain base. Parameter choice is still a little bit difficult. This is where we need experimentation. That's a general problem with protocols with all longest chain protocols like Bitcoin, like old Ethereum, that there's a lot of guesswork. So right now we have how many steps do I need until I actually trust that my block is sort of final. It is guesswork, it's statistical evaluation, so this is what we need to redo now if we want to go to these generalized adversary sets. Gasper is getting even more complex because it's a hybrid protocol. So as I said, I think I can put this into Gasper. I could implement it in Gasper, but given the analysis of it is a relatively very flexible way now to deal with validators. It's actually too flexible. So what we want is actually an attributes-based one. And I used this already in my examples. So I used countries. What we want to say is I want a quarter of the stake to fail, plus 1 country, plus 1 implementation, plus maybe 1 cloud provider, plus flashbots. And if we define it by these attributes, we give all the validators attributes, we can compute the corruption sets from saying I want an entire country to fail. We can compute back what is the set that we are implementing in our algorithm. And then our algorithm can ensure that I not only can tolerate half of the validators to fail or a third, but in addition an entire country, an entire code base, an entire flashbots client, whatever. The problem in here is, and I guess that's an issue with all diversity implementations, the more attributes I have along which I want to be diverse, the more validators I need to actually implement it. So it's easy to say I want to tolerate an entire country to fail. Saying a country plus an implementation is probably doable. Adding a cloud provider, then it's getting messy. So the more attributes we have along which I want to be diverse, the more difficult it is to actually get that implemented. And I guess that's the same also in normal diversity in real life. If I have a board of a company and I say I want more women on the board, that's fine. If I also want different ethnicities, handicaps, whatever, then at some point I need a very, very big board to accommodate all of this. So the danger we have here is that we need to avoid minority stacking, that the validators say, great, I have one validator that represents all minorities on the planet, so it's its own operating system, client nobody else uses, located in Vatican State. So such a validator may get an undue weight in the system if we're not careful how we define our sets. But in general, what that gives us now is I can give validators attributes, and rather than saying a third of the validators can fail, I can say everybody with a certain attribute is allowed to fail. And the discussion we need to have as a community is then what attributes are actually important. Is it more important to have geographical diversity? Is it more important to have client diversity? Where do we want to set the priorities, and which diversity aspects actually in the end less important? So that's my parting summary already. So plain blockchain implementations are getting serious diversity errors. We have a huge number of examples. Economic incentivization does sort of work, but it has its limits due to new financial tools, due to different business models of validators. We have a tool that we can put things onto the consensus level, that we can enforce diversity properties on that level. We know how to implement this for some protocols. This is proven, this works. Ethereum is a bit more complex. It can be implemented, but we still need a security proof. And the last thing is we can also calculate the limit on how diverse we actually can be. So we have a mathematical way to prove this is the maximum amount of diversity I can get via the consensus layer. If that's enough, that's fine. If we need more, then we need to sit back and maybe combine consensus with economic incentives or really go back to the drawing board. But we can precisely calculate now what kind of level of diversity can we have. And the legal question that comes up, which was also essentially one of the new motivations with with Ethereum now being American, does it actually also help to give us a legal document argument? Does it just make us technically more secure? Or are we also now legally more secure by saying, well, there are no blocks that can be created only in America. I always need non-American validators, so Ethereum cannot be under complete American law. But that's really the wrong crowd to answer this, but interesting questions in there. So, thank you.
Big round of applause for the flowers. We have room for 2 questions. Any questions? Up here.
Hey, great talk. Clearly a lot to think about in terms of diversity, and it's not as clear as just, you know, more clients or more countries or whatever. Do you have any thoughts on, you know, things like Lido that are building their own node operator sets and are, you know, taking it upon themselves to kind of build their own set in the way that they see a diverse set looking? You know, there's some people that say, oh, it's so great that we have so many home stakers, but like you've kind of mentioned, you know, a lot of people might not be staking their own infrastructure. They might just be running on AWS. So do you have any thoughts on like how we can kind of economically ensure that there are diverse sets, and, you know, do you have any thoughts on people that are going ahead and doing this themselves, like Lido?
Well, one thing with this approach, we could actually say that Lido is in an adversary set where we need blocks to be generated by not Lido on a very frequent basis, so they can't completely take over. They have an upper bound on how much control they can have. The approach generally isn't economical, so if it makes a lot of monetary sense to centralize this, it's not stopping it. It just gives you less weight. So the more people are joining Lido, the more weight in the consensus people get that did not. You can link this with an economic incentive. So if you also use the same approach for the leader selection algorithm, then you can also say the validators that add diversity get more block proposals, so they make more money, so that at some point also an economic limit on how centralized you can be. So it probably would be a combination that both by consensus enforcement, you say, I need validators that add diversity, but they also would earn more money, so after a certain size, it just doesn't pay off to grow much more. So it can be implemented. The only problem, again, is if you have too many axes among we want to be diverse, then we run into issues of implementability.
All right, thank you so much. We are heading for the next talk. Or is there one more question? Maybe we have room for one last. There you go.
Yeah, thanks for the talk. Is this for Ethereum also applicable for distributed validators? Like, I think it will be difficult to get the Ethereum community maybe around having something that is not cryptographically you cannot assert that a validator is in a certain country, but what I think where this could maybe lie, could be applied where distributed validators, like their SSV networks or Opal or Parastate working on?
Haven't thought about that yet. So probably could make it on a second level. I would still hope that it gets into Ethereum, even if we don't know exactly where somebody is, that we prefer semi-perfect policies over 100% cryptographically assured ones. I don't see a reason why it couldn't be used with distributed validators. Maybe it gets a little bit more difficult to define than the policies on if you have two levels. I mean, it's a similar thing already, which is a problem that hasn't been completely solved yet. In Ethereum, I have two protocols that both have different thresholds and there's different sets. So how do I combine this? I think if I get in a distributed validator, I get a third one. Should be solvable. I don't see a fundamental problem, but definitely needs to be worked out what that means and if the proof still goes through. So the main thing is you need to still prove everything still works, and that's a part that is still a lot of work.
Well, big round of applause for Kyle. Thank you so much.
Muy bien. Hey, how you doing? Of course. Buenas. ¿Qué tal? ¿Todo bien? Sí, eso es. Muy bien. Listos, listos. ¿Él va a hacerlo conmigo? Ahora le van a quitar el esto, le ponen. Así que, Eduardo, por si tienes que presentar. Perfecto. Correcto. El CEO y el founder. Sí. No, yo no soy co-founder. Llegué más tarde. Siempre, esto lo tengo que llevar colgado aquí. No, founder, no, te jodes. Ah, fuck.
Hace unos meses con la comunidad de Ethereum Caracas, que hicieron un meetup.
Ah, sí, claro, sí. Con Pablo y tal, también está por aquí. Sí. Genial. Muy bien. Vamos a ver qué...
Muy bien.
De momento estupendamente, sí. También es verdad que hemos llegado de hace muy poco, pero... Sí, pero tiene muy buena pinta. ¿Cómo te llamas, perdona?
Juan David.
Juan David, encantado. A ver, tienen traducción automática, ¿eh? Qué guay. Of course. Good luck. Eso es. Esos son los takers que entren, venga. Sí me gusta. Que entren todos.
A big round of
Hopla. Test.
It's work. Seems to be working.
Seems to be working.
¿No te lo han dado?
¿Aquí? ¿Este? No. No tengo. Those are not stairs. Vamos. Mira cuántos solo staker ahí. Que entra.
Una ronda de aplausos para esos stickers.
Aquí está.
Ah, perfecto.
¿Te dejo esto por aquí? Luego para coger una silla si viene más gente. Listo.
Genial. Test. Probando, bro. Sí.
Yeah? It's working? Yeah, I think so. A lot of people. Not bad.
Cuidado aquí.
Okay, thank you. Whoop.
Woot woot. Solo stakers, come in. Hacemos 20 minutos y luego 5 para preguntas, más o menos.
Vale.
Perfecto.
Vale. Okay. Vale, perfecto.
We have a couple of seats over there.
Full room.
Right here. Full room, guys.
Yeah.
Ooh.
Great. It seems like solo staking is really important.
Yeah. Well, Devcon organization, note this down. Next Devcon, we need a bigger room.
We need that now in the main stage.
We need that in the main stage, and we need more solo stakers. We need more talks for solo stakers. We need more solo stakers.
Totally.
Well, no further ado. Let's start the talk. Here we have Paul and Eduardo from DAppNode. And guys, the stage is yours.
Thank you.
All right. So let's set the stage. Who is solo staking? Who's staking by themselves? Nice, nice, nice. Okay. Yes. Good. Awesome. Fantastic. Who's staking through a staking pool? All right. Okay. Yeah, not bad. I would say that was 50-50, yeah?
Not bad.
Okay. Who's taking through an exchange, like Kraken, Coinbase? Okay, out of the room right now. No, I'm joking. I'm joking. You're fine. Okay, good. No, I hope the talk that we're going to have today convinces these last group of people that this might not be the best decision for Ethereum, and that it's actually not that hard to take cards into your own matter and to actually start doing it yourself. So yeah, let's go for it. This is what Vitalik published not that long ago, and this is the roadmap of Ethereum. And solo stakers are people that are not professional stakers. They're not professional validators. They're people that have their own jobs. They're people that might or might not have children. They might have hobbies. They might have other things to do than just keeping up with this. So how the heck are they supposed to keep up with all of this? And that's the purpose of this talk. We're going to try to lay down in the next 25 minutes the next things that are going to be huge and that are going to impact us all as solo stakers, and that we need to take into account and how to react with it. So first of all, to try to convince these people that are still staking with Kraken. Okay, so it is vital that there are more solo stakers. The reason of this talk is because we need to convince you that you can stake and that is actually worth it. It is vital for Ethereum, and it's actually an existential threat to Ethereum if we don't have enough solo stakers. So we all have seen this. We all have seen how a very few entities control a huge majority of the validators. Who here remembers the Steam fiasco? The blockchain Steam fiasco? Right, so actually having centralized validators or centralized it actually can do things like the Steam fiasco was Justin Sun bought Steemit, which was a company that was behind the blockchain Steam. And there were some people that did not agree with him. So he basically went to Poloniex and a few other exchanges and said, like, hey guys, take this couple milli, and we're going to vote for an invalid state transaction when the accounts of these opponents of mine are going to be emptied from one block to another. Imagine your Ethereum accounts emptied like this, invalid state transaction. This is what happens when we got centralized validators. So yes, it is dangerous, okay? But not only this, there's even a more insidious thing that's happening in Ethereum right now. Right now, we have compliant block production. Through things like MEV Boost, we have a 32% of the blocks being produced in Ethereum right now. A 32% of blocks produced that are OFAC compliant. That means that if you have ever used Tornado Cash, there's a 32% of the blocks where your transactions are not going in. Did you know that? Did you know that you're being censored in 32% of the blocks? This is huge. And this is MEV Boost. And if we go into the MEV Boost produced blocks, this is 87% come from relayers that have said that they are going to comply with OFAC. This is why it's so important, right? Okay, so brief introduction to DAppNode. DAppNode, we're here to make it easy. We're here to make it easier for people to run nodes. We provide a UI. You don't even need to be technical. There's auto updates, so you don't need to do the testing. We test for you, and then we push the update, and it will be updated. This saves about 72 hours of DevOps work per year only on Geth and Prism, for example. Then there's all sorts of nice, beautiful things like a Web3 signer that holds the keys for you, et cetera, et cetera. And there's a huge community of thousands of validators that are doing the exact same thing as you, and where you can just rely on them, ask for support, et cetera. This is one of the things that we have done. This is what you need. This is what you see. This is the UI that you will use in order to set up a validator. You need to choose your execution client, choose your consensus client, put the keys into the remote signer, or use, optionally, MEV Boost. Okay, enough. The thing that a solo staker needs to know is that you are the key for the future of Ethereum. All right, MEV. Okay, so MEV. MEV stands for maximal extractable value, and the first thing that we need to know here is that the value is extracted from who? From the user. And people say oh, MEV, but they're doing nice things. They do arbitrage between dexes, so we can if I have a token, my price will be the same everywhere. Yeah, that's a good thing, right? But how about everything else? You got price execution in every trade that you do in a DEX. You got gas wars and network congestion whenever there's a juicy MEV opportunity. You get the potential and the threat of chain reorgs if there's something really juicy and the conditions are right. And the validators are incentivized to attack themselves. So if I come after a block where there's a really juicy MEV opportunity, I'm incentivized to screw up the guy that comes before me so I can keep the MEV opportunity, right? Okay.
So yes, how to map all of this related to MEV? So mainly for me and for most of us, MEV is not a feature, it's a bug. It has a lot of implications on the Ethereum design because of that, because it's something that is leading in the wrong direction. So mainly PBS has born to try to mitigate this situation. PBS proposed block separation, and we are going to talk about that later on. So that is why the concern of the community and the researcher to try to mitigate as much as we can the MEV. And that is why we are starting to see new proposals like single slot finality. Single slot finality is a proposal to be able to have finality in just one epoch. And the idea is to remove these opportunities from the protocol itself. But also the single secretary leader election that is related to the validator anonymity is something that is also researching right now, and we are talking later on. So mainly we are seeing how the Ethereum Foundation is trying to find ways to mitigate this situation at a protocol level. But there are some things that we cannot mitigate. So far, we have seen that it's really, really hard to find a solution to MEV. So that is why the PBS or MEV smoothing is a way to make this more fair and try to mitigate these situations.
All right, so what do you need to know for MEV?
So go ahead.
So yeah, so MEV is a centralizing force. It's a centralizing force because MEV researchers will not give you, as a solo staker, a juicy 10 million MEV opportunity, because you, as a solo staker that has only 42,000, 32 ETH in this in your validator, you would be happy to take this 10 million, shut down your validator, and go live in the Bahamas for the rest of your life. So it is a trustful system, and as a solo staker, you cannot access MEV opportunities if you don't use MEV Boost right now. In the future, PBS provides the same separation of powers and allows for easier builder decentralization and removes the need to trust the builder of the block. But right now, MEV is a huge centralizing force that basically makes that us as solo stakers will only have two sources of revenue, which are block production, so block reward and transaction fees, and the big companies, the big trusted companies that can sign agreements would have those two plus MEV opportunities. So MEV Boost is, for now, as solo stakers, the only solution that we have to access this, this revenue.
Yeah, and mainly the feeling that we are having with MEV is that we are putting the incentivization in the wrong place. We are incentivizing people to extract this value from users. So that is why we should try to find a way to remove this from the protocol.
Okay, DVT. DVT is the next hot topic, and it's distributed validators. So right now, there's this equality of one validator key, one validator client, which basically means that whoever runs the machine, whoever runs the validator client, also has access to that key and can do all sorts of bad things to this. It can slash you, it can ransom you, it can just exit you, it can just shut the validator down so you get inactivity leak. And DVT comes in. So the DVT comes in, so you can split the validator key in different key shares and distribute it over many validator clients. This allows for high availability, but because imagine these validator shares as a sort of like a multi-sig. So if 3 of these shares are online out of 4, so if one of them are offline, we can still continue validating. It also allows for different trust assumptions because you can distribute these shares. So nobody with one of these shares, you can't slash people, you can't exit, you can't do all of this stuff. So actually, we do not require so much. We can afford to give these keys to other people and not require so much collateral. Right now, Rocket Pool still requires somebody to put 16 ETH, huge amount of collateral, because that's what they can get from, that's how much damage they can do. So with DVT, we get a different trust assumption and the potential for lower collateral requirements. Moreover, those who already run nodes and already have a validator set up, they can monetize through DVT technologies on top of their validator sets. So it's a way to bump up your rewards for having a validator. Okay, so that's exactly what you need to know about DVT. You'll be able to monetize your machine by leveraging other protocols on top of it. These protocols are like SSV Network or Obol or Diva, and the people will be able to participate in validation even with less than 32 ETH. Because you can do a setup and then you can participate in this, which is great for accessibility because we're making part of the benefits of running infrastructure to people that are not rich, to people that do not have 32 ETH. So it's great for accessibility. All right, withdrawals.
Yep.
Withdrawals, that's what all we're waiting for, right? Like we've got this 32 ETH. Withdrawals are going to be a new system level operation, which will have no gas cost, and they will not even go to the EVM. They will increase the balance of the withdrawal address automatically. It'll be a limited block per block, just like right now joining as a validator is also limited block per block. There's a limited amount of people that can join the validator set. The same thing will happen with withdrawals. And what we need to know is that we will be able to get our money if we want to. Now, there's something more interesting to think about here, which is what will happen when people are able to take this? Will staking pools be, will people take out of staking pools and start solo staking? That's what we're hoping. Or will the opposite happen? So What's going to make it easier to convince people to take out of staking pools and centralized exchanges and start running it themselves?
Yep.
All right.
So yeah, now it's time to talk about prototype sharding and the future of Ethereum. So mainly, the roadmap of Ethereum changed completely at the moment that Vitalik made this Reddit post. So mainly we realized that if we facilitate rollups, they have better scalability and potential than the previous execution shards. So mainly everything changed at that moment. We forget about having execution on the shards, and we move to a way to provide data availability for other layer 2 applications that are going to happen during these years. So mainly the thing that happened with prototype sharding is that instead of providing more space for transactions, we are going to provide more space for data that the layer 2 solutions can use it in the future. So the idea is mainly that the execution is going to happen on these CKVMs and rollups, keeping the execution part of Ethereum as it is. And mainly from the point of view of Validator, is just a way to validate the data that is available. So it's not going to include the need of validate this data as in the state of Ethereum. So yeah, what you need to know about this? Mainly the Beacon chain is going to store these new blocks, and the data is going to be it's going to be used by the rollups. So mainly the idea is that you get a vertical tree, a proof of this data, and you can use a precompiled smart contract on Ethereum that validates this data, allowing them to verify the state of these layer 2 solutions. Yeah, mainly the idea behind this is like a solution like the CKVM, like a Polygon announced yesterday, that are going to be able to have a proof of the state and take the security of Ethereum inside these layer 2 solutions. So mainly, Ethereum is trying to provide these new tools for these kind of solutions, making the scalability go in that direction.
So what do we need to know? We need to know that those blobs, those new blobs of data, will be stored in the Beacon chain, which will mean that our Beacon chains as validators, solo stakers, will grow, will bloat. But hey, it will not grow indefinitely because this data will only be stored for about a month. So that's great. So we'll have our Beacon chains will not just continuously grow and grow and grow, at least the part of the blobs, but every month we'll be deleting this data. So it will grow, but it will not grow indefinitely. All right.
Yeah.
Next big topic.
Anonymity. Yeah, that's also a critical point of the network. So yeah, the thing is, since we are using random in the Beacon chain to select the validator proposals, it's possible to know beforehand who is going to be the next one. And since we are using the P2P network to communicate with these nodes, it's also possible to get the IP of the nodes. So mainly the thing is that since we have also MIF in this situation, people want or could try to attack these nodes because they can get the minor extraction value or the maximum extraction value from the block. So at the end is the same problem that before. We are putting the incentivation to attack the network. So we are making right incentivations for the solo stakers. But this is not just that. The thing is, the single secret leader election is a protocol that is going to allow to hide who is going to be the next proposal. And with that, you can protect these kind of attacks. And this is something that is already in development in the protocol, and it's obviously very important to protect the privacy of the validators. So what you need to know about this? Because the list of proposers of the new epoch are known, it's possible to be targeted by these attackers. This new protocol protects the privacy of the validators at the moment to propose the block, but we need also new ways to hide the communication between nodes because the IP is still exposed. So that is why private solutions like Hopper or other can provide this kind of privacy protection at IP level.
Right, next hot topic, statelessness and PBS.
Yeah, a good one. So yeah, this has been a hot topic in the research part of the protocol from several years ago. So mainly the thing that we have right now is that we need to have all the state of execution client to be able to verify the next block. So this is a problem because we are taking all the complexity, all the historical data from the Ethereum, and we are need to store this in our devices to be as solo stakers. So mainly the proposal is to try to remove this complexity with the idea to be able to verify a block without the need of having all the state. So the big idea is just to have a witness of the state at that moment. And if you have this proof and this witness, you can validate that the transition from one state to the another one is correct. So mainly, the good part of this is that we can remove all the state of Ethereum and just to have a very small proof of the current state and be able to verify a block.
So, Edu, you're telling me that if we create a block through this through this witness and through this proof, we can prove only the parts of the state that we need to prove that this block is valid and include it in the block itself. So a validator of the block will be able to look at the block in itself and and it'll include this proof, so it'll be able to tell if it's valid or not.
Yeah, exactly.
Which means that we need to link this with, okay, so we're starting to separate who does all of this proof production and who does the validator work. So, PBS.
Yeah, PBS. PBS is going to be also a very important part of the protocol because the thing that Paul just mentioned. So mainly the idea is that we are going to split the roles on the network. We are going to have proposal and block producers. So mainly the idea is that the block producer is the one that is going to create all of these to generate the witness, and is the one that is going to take this high computation. We don't have too much time, right? Okay. So yeah, the idea is just to put all this computation in the block producers, and the validators are going to be more or less the same. So they only need to validate this proof in a short way.
So what do we need to know?
Yeah, mainly that the hardware requirement for holding the state disappears, and that is really, really good. And also, if we link with the blob things, it's like, okay, we are getting more space here, and we are putting block there, so more or less we are going to be the same. It's going to increase the bandwidth, but not too much, because we are going to move from partition Merkle trees to Merkle trees that are more efficient ways to prove the state. So mainly as a validator, I think the result is going to be more or less the same. It has been always a need that validators need to be running custom hardware, so we keep on that level.
Okay, I'm going to take the dank sharding and data availability sampling. Okay, so this is going to be the last thing, and the key part that solo stakers need to know right now about this is that we do not know which are the consequences that it will have. So we cannot possibly know right now because there's not a specific implementation of the data availability sampling. So data availability sampling, what it will allow us is to remember those blobs of data that we have mentioned before. So these blobs of data will not necessarily be fully downloaded. We'll be able to just prove a sample of this, to take a sample of this data and prove somehow that, that this exists and this is valid and available for download. But we do not know yet what's going to be for solo stakers because there's too many moving pieces, and this is way too far away. So for the moment, for solo stakers, what it matters is the proto-dank sharding, the existence of these data blobs, etc. So to summarize very, very quickly, on the topics that we have spoken, MEV, it's a bug, not a feature. It's a centralizing force, and it screws up our censorship resistance. For DVT, we will be able to leverage our setups to earn extra rewards. For the withdrawals, pretty self-explanatory, we'll be able to take our deposits out. Proto-dank sharding, our consensus layer will grow with these blobs of data. Validator anonymity, a single secret leader election will save us from the MEV extractors that come behind us, and they want to get us offline to get the MEV opportunities. Statelessness is that we will have less drive requirements, but we will have more bandwidth, and dank sharding that we don't really know. So in 25 minutes, this is everything you needed to know about the next phase of Ethereum. Thank you very much.
Thank you.
The room was full, so maybe questions can be taken outside. Thank you, everyone.
Great.
Sí. Muy rápido, ¿eh?
Por ahora que ya llevo en la cuarta charla, casa llena con el mayor.
Ah,
Yo creo que es la primera vez que llenamos,
Sí,
así-
sí. Sí. ¿Qué?
Ha
¿Te ha
molado
gustado?
mogollón, Joder, Paul, claro, no parte. El-
Yay.
Brian, nice to meet you.
Good to meet you.
Yeah, I've been using Dap Node since like day
Sweet,
one, man.
Oh, that's nice. great. Oh, that's awesome.
So I'm in the Discord as Beast Smokes, if you've ever seen me.
Which one?
Beast Smokes.
Smokes, yeah.
Yeah, so I'm like, I'm
Wow, okay, wow, it's so cool to,
Yeah,
to put
to put
faces to the names.
Yeah, right.
That's
to, like,
amazing.
finally meet you guys. And I saw that you guys were doing the talk. I'm like, oh, I fucking have to go.
Yeah, I hope it was useful.
Yeah, very much so.
Really complex. It's very, very complex.
Yeah, but luckily you guys make it so easy, and I don't think people like understand how easy. Yeah. It's like I'm not a dev, and I built my own computer. And
That's why.
¿Hablas español? Not really. No, it's okay. It's okay.
Are you guys staying for the next talk? Because there will be people coming in. So who is not staying?
We have more room here.
Great. ¿Lo prendiste? Good.
Wasn't there a phone? Didn't anyone find a cell phone? On the floor or somewhere?
On this side, we have more seats. On the left side of the room.
Good. Gracias. Oh my gosh. Yes.
I'll look at the screen. I think it'll be 25 minutes, but if I have time, I would love to take questions. But I have a lot of content, so.
Good luck, you're going to do great.
Thank you. Should I just start? Okay. Hi, everyone. Thank you so much for coming. My name is Christine Kim. I'm a research associate at Galaxy, and today I'm going to be talking about the distribution of ETH supply since the network's genesis. This is going to be a two-part presentation. First, we're going to discuss how 60% of total ETH supply today was generated all in one single block, and how that very large sum of ETH got distributed over time. And then second, we'll discuss total staked ETH supply, which is actually a very small percentage of total supply, but now it has an extremely outsized impact on network security and censorship resistance. So before I dive into the data, I want to elaborate a little bit on why I think this is such an important research topic for Ethereum. I started investigating this back in the summer because it was becoming clear that Ethereum was soon going to transition to proof of stake after many years of delays and lots of uncertainty around whether this upgrade would happen. And this would mean that soon, and today, now that the merge has happened, the amount of ETH that users hold can be directly translated into influence over Ethereum's consensus and block building process. So to understand how resilient Ethereum is against attacks, such as, for example, like a 51% attack, one of the key questions to ask is who controls staked ETH supply, and how easy is it to seize control of staked ETH supply? And the more concentrated that your staked ETH supply is, the easier it is to disrupt network consensus. It's like a centralized point of failure. But the less concentrated your staked ETH supply is, the harder those types of attacks are. And the second reason is very closely related to security. It's one that goes part and parcel with security, and that's because the supply distribution of Ethereum, it matters more than ever also to the decentralization of Ethereum, and that relates to censorship resistance and credible neutrality, because validators are now the block proposers of Ethereum. They are the block proposers of a proof-of-stake blockchain. And for those of us who are from the US, this really does matter also from a regulatory point of view, because for regulators like the SEC, decentralization is a key criteria determining what type of financial asset ETH should be classified as. And finally, the third reason is because this topic helps to illustrate who the biggest winners are from proof of stake, from AKA the merge upgrade. The biggest ETH holders on Ethereum are in the best position to profit now that the merge upgrade is complete. And the capital that they hold will now be able to generate more capital on the network. So whoever holds a lot of ETH now stands to generate and continue to hold on to a lot more ETH. And this is a little different from proof of work mining, where miners were to some extent incentivized to sell off their ETH due to their high operational costs. So when you're mining ETH, you sell it off once you've mined it because you have to pay a very high electricity bill. But for validators, that's not the case. The operational costs are, in comparison, extremely negligible. So I hope this has got you interested. So now on to the data. As of the beginning of October, about 120 million ETH has been generated on Ethereum since Genesis. This value, there's actually quite a lot of dispute around the exact decimal points of the value, but for that conversation around some of the nitpicky stuff of how we even know what ETH's total supply is, I encourage you to read the full report that I've written on this research topic at galaxy.com. But more than mining or validating combined, the majority of supply was allocated before the network even launched. So 60 million ETH, representing about 50% of total ETH supply today, was distributed at the network's genesis to participants who had who were involved in the initial coin offering. So the ICO sale of Ethereum basically sold off ETH to the general public. Anyone with an internet connection who had Bitcoin could participate in this fundraising effort for Ethereum. And that sale took place in 2014, a year before Ethereum even launched, and it raised funds for about 42 days. Around $18 million was raised at the time. Now, the second part that I want to highlight is 12 million ETH, so roughly around 10% of Ethereum's total network supply, was also generated at Genesis, and this ETH went to early project contributors to Ethereum and the Ethereum Foundation, which is an organization that was set up to help steward the development and the growth of the Ethereum ecosystem, which if you guys were there for the opening ceremonies, Aya had a really good talk of what her vision for the EF is. But for the 12 million ETH that was generated, it was basically split up between the foundation and a bunch of founders. So like some of those names, big names, are like Vitalik Buterin, Charles Hoskinson, Mihai Lisi, Gavin Woods, Joe Lubin. There's more. But it's not clear the distribution of how much of that 12 million went to those contributors. And we also don't know exactly what the full list of contributors were at the time. There's sources to say that it was split up around 85 early project founders. So a lot of critics of Ethereum do note that the distribution of coins through processes that take place before the public launch of a cryptocurrency, so before mining starts, before validating starts, this is called a pre-mine, and it can be easily manipulated by a few select insiders. And it's not a very transparent process to understand who got what. And to some extent, this is very true. If there's two really great books that discuss a lot of the drama and the difficulties around figuring out how much of this ETH should be distributed to early project contributors. Laura Shin's Cryptopians and Cami Russo's Infinite Machine are two books that discuss that history. And when you think about the ICO, there is on-chain data to show that, that 60 million ETH, it was distributed across 8,800 different on-chain accounts, which sounds really decentralized. But the thing is, we don't know how many of those accounts were actually owned by the same person. It's a very difficult, there's known videos explaining how you could actually participate in Ethereum's ICO using multiple fake identities. So there's no way to really double check how clean the ICO was and how, according to the rules, people were playing at the time. So from Genesis, it's very hard to know how decentralized ETH supply was. And in some ways, it does look like a bunch of insiders were getting a really big part of the pie. So for the next few slides, I really want to do a case study on some of the biggest ETH holders from Genesis and explain and hopefully show you that we can see a lot of evidence to suggest that Ethereum supply has distributed a lot over time. So let's start with the Ethereum Foundation, the biggest publicly labeled account on Etherscan. And you might be asking, well, what if Ethereum Foundation has more accounts on chain that we don't know about? Well, as of March 31st, 2022, the Ethereum Foundation self-reported their financials. They said, hey, everyone, in the spirit of transparency, here's how much ETH we control today. And they've said and self-reported that they currently only control about $1.3 billion worth of ETH. That's probably less now that ETH price has gone down a little bit since March. But that represents 0.3% of total ETH supply. So we went from 12 million to now 0.3% of total ETH supply. And the EF has sold off some of their ETH to hold other assets. And a lot of this analysis I will explain that it depends on self-reporting. It depends on these individuals, major individuals, to self-report how much ETH they still hold. So Vitalik has talked about this openly. I've asked Joe Lubin on stage at CoinDesk Consensus, like, how much ETH do you hold, sir, now? And his answer was basically like less than 0.5%. But of course, not everyone is super altruistic, and not everyone is gonna just like explain how much ETH they hold. So it's worth also looking at some on-chain data. Who are the biggest ICO recipients? Well, the top receiving address from the ICO received 1 million ETH. And over time, outflows from that account reveals that the funds have been dispersed to several other accounts. So this one account that received 1 million ETH, you can see that they sent some of that ETH to centralized exchanges. They invested in the DAO, a very infamous token sale back in the day that caused the Ethereum Classic creation, different smart contracts. And a lot of these flows actually converge to one account, tertiary account domain called Fraternity ETH. And that account only currently holds about 800 ETH today. Shout out to Breadcrumbs, who was able to create this visualization and be able to track the flows out of that account over time. And similarly, if you do this same exercise for the second and the third top accounts that received the ICO, they received around 935,000 ETH and then 933,000 ETH. That's the second and the third largest recipients. 95% of the funds that they've received has since been transferred over to centralized exchanges. So that basically means that the funds have been moved off chain. They can't be really traced without further supporting evidence, but the movement of funds to exchanges generally suggests that the funds have either been sold or traded. And that's kind of like a case study of the three. But if we take a little bit more of a broader look at where all of the ETH has since flowed to, this is data that was compiled from Nansen, but it sums up the first outgoing transaction between 2015 and 2018 from accounts that received ETH from the Genesis block. And it shows that the top 10 receiving entities, it shows like the top 10 of like how much ETH they received, and most of them are exchanges. Only 2.3% of Ethereum's pre-mine supply was held unmoved from 2015 to 2018. So this analysis does suggest that many investors that did participate in Ethereum's ICO likely sold off their ETH within the first 3 years of the network's launch. And on-chain data of the known account balances of these early ICO investors and talking with self-reported figures from project contributors, many of them have not retained that large supply of ETH over the years through market fluctuations, through the evolution of Ethereum's dApp ecosystem, and of course, it wasn't clear exactly when Ethereum would transition over to proof of stake, 5 years ago. This has been a very long time coming. So in the report that I have written on this topic, I actually go into a lot more detail using other on-chain metrics, like a bird's eye view of Ethereum supply. Holistically, I use metrics like HODL waves, supply equality ratio, network distribution factor. So definitely be sure to check out that report if you want more supporting evidence for this idea that Ethereum supply distribution has changed over time, and how the biggest winners of the proof of stake merge most likely aren't the ICO recipients and early founders. That report is on galaxy.com, but because of limited time, I now want to jump to showing you guys some data around total staked ETH supply and how we're seeing that data kind of evolve over time and the trends around staked ETH supply that we're seeing over time. Great. So in comparison to how much total ETH supply there is, only roughly 12% has been staked on Ethereum, which is kind of small. That's $18.5 billion on Ethereum. And that's very surprising kind of to me, because if you're not staking your ETH, you're essentially getting diluted. And liquid staking solutions basically means you don't have to make that trade-off of, oh, if I lock in my ETH, then I can't use it for DeFi applications. It's surprising that it's only at 12%. But that's probably because, number one, you can't actually withdraw your stake right now. There is a big risk factor in that, Shanghai, we're not exactly sure when Shanghai is going to be. And up until very recently, until last month, it was very uncertain when the merge would actually happen. And there were tons of risks associated with the merge that probably made people a little bit iffy about, should I be staking my ETH into the Beacon chain? So there were core developments in the protocol that needed to happen in order to grow more confidence in staking your ETH. And so I actually suspect this figure to start rising now that the merge has happened, and especially after Shanghai is complete. And you can see that this trajectory, year over year, it's getting higher and higher. And if we start to see more total supply of ETH become staked, it's important to ask the question, who's holding that ETH, and how has that distribution changed over time? So for the past, since 2020, since when the beacon chain started, you can see that initially, independent stakers, basically stakers that were not associated with a staking provider, it was pretty high. It was around 70% of the total staked ETH supply was controlled by independent stakers. But over time, we can see very quickly that we're starting to see more concentration, see the black, to staking providers like Lido and Coinbase. And of course, take some of this data with a grain of salt because this requires on-chain address labeling, which is not always an accurate science. And shout out to Hill Dobby, who's like a Dune analytics wizard, because I basically took his dashboard. But so why? Why do we see this happen? Why do we see it going from 70 to like smaller? Well, I think number one, it's because it's a lot easier to stake with a staking provider than it is to run your own validator node, especially after the merge with the execution layer client and the consensus layer client, and making sure that those communications happen in the right manner and not getting slashed. It is much easier to just kind of offload that technical capability to somebody else and ask somebody else to run it. And the second thing is you can't actually have liquid staking if you're an independent staking provider. There's a ton of benefits of going to Lido and then being able to rehypothecate your stake ETH and get additional yield. So I think a big plus of Lido is this idea of liquid staking that you don't get as an independent staker. And then finally, this is a more theoretical benefit of joining a large staking pool. But theoretically, if you join a staking pool that has control over more than 1/3 of the ETH, or like key thresholds like 1/2 of the ETH, then you also have this ability to theoretically achieve outsized profits by deploying multi-block MEV strategies, and you're able to like manipulate block times and do these fancy things that you can only do if you're a very large staking provider, and in those ways like increase your reward. So left unchecked, I really do think that this trend of increasingly centralized players dominating the staked ETH arena, I think that's a trend that we could start to see grow a lot stronger over time if we don't start talking about solutions now. So for the last slide, I wanted to talk about some of these solutions. And I'm not going to go much into distributed validator technology because that was explained in much detail in the last presentation. So the first one, it was proposed earlier this year by Justin Drake, and he suggests the creation of a liquid staking derivative token called LSD, which is the name of a drug, but it stands for liquid staking derivatives. Yes, and this would basically allow independent node operators running their own validators as opposed to other to that of other users, you'd be able to enjoy the benefits of basically rehypothecating your assets without having to rely on a staking provider like Lido. And this setup would really circumvent that need for you to trust in a smart contract that may contain like smart contract risks and bugs. But of course, this would require a really heavy and major code change to Ethereum's consensus mechanism, its protocol and its design. And as you saw in the last presentation with dank sharding, statelessness, all these other things in Ethereum's roadmap, it's kind of hard to think that liquid solo validating is in Ethereum's near future. But it is a solution or a potential proposal that has been discussed. But I'm just saying, it would require a lot, and there is a lot on Ethereum's development roadmap, as you probably noticed from the last presentation. The second one, which is a more short-term solution that many Ethereum community members have been advocating for, is basically just altruistic behavior from the top staking protocol. So Vitalik was tweeting earlier this summer about this idea that maybe staking pools should just altruistically start increasing fees for users if their share of the staked ETH supply goes above 15%. Or maybe, the individuals like Lido should start self-imposing like deposit caps into their smart contract so that their portion of staked ETH supply never goes above like 20% or 25%. And I think that this kind of goodwill behavior might seem very laughable at first, but it's happened time and time again on Ethereum's protocol for other issues. So MEV is a really great example where we saw a lot of altruistic behavior from key ecosystem players. Before Ethereum merged, there was Ethermine, which was the largest Ethereum mining pool by hash power, and they publicly tweeted about refraining from MEV opportunities that don't align with the ethos of the Ethereum community out of support for the longevity of the protocol. So they're basically leaving money on the table, not interacting with certain MEV strategies because it's just bad and they're not going to do that. Flashbots recently tweeted, we're going to start giving blocks to other relays because we just want to bootstrap other relays and we want to help out the ecosystem. Ethereum 2.0 client diversity, consensus layer client diversity, even though not all teams are have the same resources and they have the same track record for performance, there was a huge push by the community to just encourage minority clients to gain more user adoption. So time and time again, we're seeing a lot of altruistic behavior encouraged, and I actually hate this kind of solution of just relying and encouraging the altruism of ecosystem players to keep Ethereum safe. But I put it on the slide because it's worked for other solutions before, and we've seen examples of it happening on Ethereum, and it was one of the proposals around this topic for how we want to see staked ETH being more decentralized over time. And then the final one is distributed validator technology. I won't go too deeply into it because, again, it was talked about in the last slide. But this, I will also specify, is an active research initiative. OBOL and SSV are two of the few projects in this ecosystem that's really trying to make DVT a reality. And I didn't really in this presentation go much into how MEV Boost is actually changing the dynamics of how validator node operators are competing with one another. But as with many aspects of research and many topics of research on Ethereum, once you research one topic, and propose solutions, it actually impacts and has many third-order consequences to other areas of Ethereum's development. So as I close out my talk, I'd just like to reiterate that the supply distribution of Ethereum matters now more than ever because Ethereum is a proof-of-stake blockchain, and the solutions that I discussed on this slide are really far from perfect, and I urge a lot of developers and stakeholders and people in this audience to think deeply about how supply can become more decentralized and distributed over time, because left in its current form, there is this danger of it trending towards centralization. So that wraps up my talk. Happy to answer any questions. Email and Twitter's there, and yes.
I think we have space for one question.
Okay.
Who got the mic? Maybe they were intimidated by that much data. Amazing research, Christine. We have 1 minute. Or
come on, guys. Any questions?
There you go.
Hi, how are you? How do you imagine the role of Latin America in terms of decentralizing the offer of ETH? I mean, or not the offer, but the staking of ETH.
Sorry, the what?
How do you imagine the role of us, Latin America,
Latin America,
regarding this problem?
Latin America regarding this problem? Well, I think many of the validator node operators are probably based out of North America. So I think the fact that we're having this conference here and the fact that we're talking more about Ethereum in other areas of the world that maybe many developers haven't ever interacted with, haven't ever come to visit and know more of the population here and more of the ways in which we can have more validator node operators, independent staking node operators from Latin America. I think that would contribute significantly to the security and the decentralization of Ethereum. So I think it's really great that we're talking about this here and that we have a great audience of people who can bring other perspectives and other ideas so that it's not all from a perspective of we're all educated from universities out of North America, but many different ideas. So yes.
Actually, I can answer that question. There is a group in Argentina called Sensei Node. They are pushing for geographical decentralization, so you should check it out then. There you go. Okay. Thank you, Christine. Big round of applause. And
people that are going to stay in this room, stay. We have a really interesting talk next. And the other ones, please go for your next talk.
Hi. Oh.
I'm trying to find your Twitter.
Oh, you should do the Kim. There's the. Hi.
It's a pleasure. It's a really nice talk. I really like it.
Thank you.
Is that working? Please outside because we need to switch speakers. No problem. No problem. Otherwise, it's going to get like a bottleneck here.
Gracias.
Christine.
Espectacular. ¿Español?
Sí, señor.
Perfecto.
Español.
Gracias.
Yeah,
for sure. Quitar eso.
Mira, lo que pensamos con Shin es... Shin, hacemos así. Creo, yo hablo casi 20 minutos, 18, 19. Después pasa él y después I'm telling him how to organize. Juan. So we can do 20 minutes, 19, something like that, and then he can come up, and then we can do questions together at the end. Does that work?
So, but
Like,
I think my concern is maybe people want to get for Shin talk. I don't know, maybe people are running out of talk. As you want.
I'll do it. We don't care.
You don't care?
No. Are you cool with that?
Maybe what we can do is like we can do like a break. Yeah, we can do a break, I think.
Break?
So because
No.
people are going to be coming.
But then you won't get extra time. Then you won't be extra time. If you want the extra time, you have to start early.
I see.
I think it's mostly the same audience, but up to you.
Then it's okay. Maybe people are coming for this is maybe I think it's okay. Or let's try to think on like some interaction between you and questions and 30. Do a recap.
Yeah, he's gonna take he's gonna go do that. So the talks are strictly connected. So it will be a little awkward is like there's 10 minutes between the talks because there won't be enough questions to fill 10 minutes.
Are people coming?
Yeah.
Not only just like for Jin or because of the.
My impression is that the room is small enough that and our talks are connected enough.
We can if in the end we see there are much more demand, then maybe we can do it.
No, but it's gonna be full. It's a very small room.
Okay.
What I'm saying is there's not gonna be exchange of people. Like the people that are listening to me will also be wanting to listen to you. So if it's full in my room, like there's not gonna be room. Up to you. Huh?
People want to get inside.
Yeah.
We can help people get in.
I think and it will be fun to do the questions together at the end, but if I have to fill, I can take questions after my talk. So let me know. You two decide, and let me
A really hot topic, so if you guys want to be here in the front row, just like sit on the floor, we want to maximize the room, still be safe. So, and this is going to be interesting talk. This is not MEV, is the title for this one, and the next one is this is MEV. So I will do a quick poll. Please raise your hand if you plan to stay for the next one. Whoa. I will do it like the other way. Who has another talk that they want to really attend and you're going to get outside? Just one, so it's going to be full room. Yeah, let's try to fit as much people as we can. Maybe here you can sit down. And maybe it's super hot, guys.
Yeah. It would get spicy. I don't want to.
So the volunteer over there, please just like stop.
You should
or
come up
just close
as
the
soon
door.
as I'm
We
like
are
done.
almost
There's
full.
no point in you not coming up as like, and then we can take questions together.
Here we have at least 5 seats in the floor, so if anyone wants to come.
Yeah, sure.
Just like 5 more, if they want. We can fit at least 5. 1, 2, 3, 4, and well, huge audience, Alejo. I remember we were talking in Buenos Aires. You were doing a presentation where this is MEV, and now you're going to do this is not MEV. So, with no further ado, please, Alejo Salles to the stage from Flashbots.
Hey. Hello.
The clicker.
I have the clicker. Can you hear me? Yes. Thank you.
Let's test that out.
Okay. Whoa.
No spoiler.
All right. Welcome. Thank you all for coming. A friend of mine recently shared this picture with me with the label MEV. And sure enough, right, it's very reminiscent of the mempool wars between searchers trying to snatch an opportunity, right, from each other, try to get early, try to overbeat the other one, right? But is this a good metaphor for MEV? Is this actually MEV? People in the community now are very MEV aware. Proof of that is that there's 18 talks in this Devcon around the topic of MEV. There were 0 in the last, so that's quite a testament for this. Despite this, I would argue that we're not 100% sure of what MEV even means. This is a poll from last year. So which of the following is not MEV, right? There seems to be rough consensus around front running, but much less so around transaction fees, liquidation rewards, and like all of these are MEV. It's very evenly split. This one is more recent, right? Like the last year, from last year to this year, there has been many developments, as you all know. This is a recent one from last month. Are block rewards a form of MEV? This is pretty impressive. It's almost half and half, right? So it's really a contentious concept, right? This is perhaps a more trolly one. Conference swag is a form of MEV. I won't go through this chart. It's a lot of fun. I encourage you all to check it out. Essentially, there's 2 dimensions that are taken into account here. One is value, and one is extraction. So depending on where you sit on each of these variables is what you should consider MEV or not. But are these the only dimensions that are relevant, right? So again, doesn't seem like there's a lot of consensus. This is the ultimate one. I hope nobody got robbed. I really hope so. But yeah, so I think this meme illustrates, it's also my favorite meme format. It's not mine, by the way, but I think it illustrates what I'm trying to get through to you today, right? Like, so we've been calling MEV a lot of things. And so in this talk, so in my work in trying to formalize MEV, I've been argued that there's no consensus on a formal definition of MEV, and there's many around there, and we're using different things, and it's hard to come up with a formula. But in doing work for this talk, I realized that there's not even consensus on the concept, right, on the intuition of what we want to call MEV. So in this talk, I want to go through different ideas and say why many of these are not MEV. And crucially, this talk is tightly coupled together with my friend Shin's talk next, who will tell you what actually is MEV. So I encourage you to stay. He's going to roast me and tell you why the things I tell you now are actually wrong. So you should definitely stay. It's going to be a bit of a shorter talk, and he's going to give a longer talk. And perhaps if the MC allows us, we can do questions at the end. So, yeah. So since you all said that you were going to stay for his talk. All right, let's get going. So, yeah, oh, I forgot. I have like a cool animation transparency. Okay, just to tease Shin's talk. Okay. Let's get going. So we're going to start with like a trivial example, right? Is MEV, are all the things that are MEV also all the things that are value, right? Is value the same as MEV? Right, this is a trivial example. We can easily argue that this is not the case, right? That there's more to MEV than to any value. You can think of picking up a $1 bill on the street, right? We wouldn't want to call that MEV. Hopefully, you all agree. But this is still value, right? So again, this is a trivial example, but just to set the stage of the type of argument I'm going to be doing. And critically, this is all intuitions. There's no proofs here. I'm just trying to hone in a concept, and it's up to all of us what we decide to call MEV, right? It's a matter of choice. And there's no, like, again, proofs here. Okay, so first non-trivial example, is MEV equal to the set of value on the blockchain, right? So if you think of the definition, the original definition in the Flashbox 2.0 paper, there was like value that can be extracted by miners, by censoring, reordering, transactions. So there's a lot of blockchaining concepts there, right? Transactions, miners, etc. So it might well be that, okay, what we're calling MEV is nothing else than value on the blockchain. And sure enough, there's things that are value on the blockchain that are also MEV. ARBs are one of them, and I'm going to be using ARBs like a canonical example of MEV. ARBs, like talking about arbitrage on a blockchain, for instance, right? But are there things that are value on a blockchain that are not MEV? Well, here one could argue that, okay, if I do a simple ETH transfer, right, then the miner has no way to extract that, so we can call that value on the blockchain that it's not MEV. Although, put a pin on this idea because we're going to come back to it because it's not as simple as it looks. Even a simple ETH transfer can get trickier. But in principle, we can say, okay, there's some value on the blockchain that's actually not MEV. How about the other side, right? Let me also say that mostly for the question of this is not MEV, we're going to be thinking about the right side of these slides, like the inclusion of the pink set on in the white set, but we're going to find interesting things along the way on the left-hand side too, right? So we're going to also comment a bit on those. So in this case, is there MEV that's not value on the blockchains? This is, again, a matter of choice, right? But I would argue that we are striving for a more abstract general concept than value, and that's strictly on the blockchain. I don't see anything special about blockchains in terms of value. Blockchains are certainly special in terms of coordinating devices, but I don't see them as, like, again, providing value, a characteristic that's so special, right? So in general, we would like to think of MEV as something more general. And here the canonical example you can think of is a centralized exchange. In a centralized exchange, you have all the orders coming and the operator can decide to extract value from users, like Robinhood does. That's the Robinhood business model, right? So we might want to call that MEV. And matter of definition, you might not agree. Feel free to come and chat if you don't, but in principle I would argue that perhaps we want that. One subtle point here is that we might need this if we start quantifying centralized exchange versus decentralized exchange ARBs, right? So if we have value flowing in and out of the blockchain, then maybe when we start quantifying this kind of arbitrage and so on, we might need to call that MEV if we want like the whole calculation to be sound, right? So, okay, so value on the blockchain doesn't seem like it's the best candidate for our concept of MEV, so let's move on to the next one. Is MEV the same as front running, right? Okay, we start with the intersection of these sets. Trivially, ARBs, again, as we saw, I'm gonna use always arbs here. The first leg of a sandwich, for instance, you can think of it as an arb. This is clearly MEV, this is clearly front running. Okay. How about we'll start with the left side here. Also, obvious point, there's clearly MEV that's not front running. You can think of back running, trivially, reorgs, other things. Okay. So here the tricky part is on the right side. Are all things that are front running MEV? Okay, and thinking front running here is you learn some information from other parties, and then you are faster than the other in catching or capturing that value. Is that MEV? Again, the rugby example in the first slide, right? So here you can take two paths. You can say, okay, let's look at the rugby example. Okay, maybe I don't want to call that MEV, even if it has the characteristic of being faster than the other person. And so there has to be something else for us to call being early MEV. Because being early, again, doesn't have that much to do with the structure of the value itself. So here, okay, what's the missing part here? Perhaps we can think of a coordinator that is doing the allocations of value, right? And in the rugby, there's no really meaningful coordinator. You can think of, I don't know, gravity as a coordinator, but it's a coordinator that cannot extract. It's like a dumb coordinator. So here, if you have a smarter coordinator, what happens is that the game theory gets more interesting, right? So the MEV concept becomes much richer. So here, okay, this is one path you can go down, and you can say, okay, not all front running is MEV, because for it to be MEV, we need some extra player. So this is perfectly fine until you start thinking, and okay, you can think of the example of the Arbitrum chain, right? In Arbitrum, you have a first come, first serve centralized server that cannot extract, and then people are doing arbitrage. So if you go down this path, considering that the coordinator there cannot extract, you would not be calling Arbitrum arbs as MEV, right? And this is something many people would frown upon, right? And in fact, the Avalanche devs at some point were saying, okay, arbs are not MEV. And the searchers were laughing because they were saying, okay, call it what you will, we're making millions of dollars out of this. So I think there's some consensus that, okay, these type of things are MEV. So again, tricky, contentious point. It's a matter of choice whether we want to call that MEV or not. Okay, so this, again, question, is the set of things that are front running included in the set of things that are MEV? And we'll come back to this at the very end. Okay, next set. Is MEV the set of things that are MEV equal to the set of things that are permissionless value? Trivial example in the center. Arbs, right? This is permissionless. Anybody can make an arb, and it's also MEV, canonical example of MEV, so that's fine. How about the left side? Are all things that are MEV permissionless? So when I work with definitions and formalization of MEV, I argued for the importance of permissionlessness in the definition, because there were many definitions out there that included the notion of a player that can extract a value, but this is very tricky. And it's tricky because you can think of an example where you have an airdrop, right? You have an airdrop that's only entitled to you. And when you are going to claim the airdrop, the miner cannot do anything, right? So there's no way that miner can steal that value from you. So I would say, okay, permissionless looks like it's important in the concept of MEV. Although, if you think of another twist to that example, say you have an airdrop which you can only claim at a specific block height, and say that the proposer of that block knows about this. So then they can credibly extort you and tell you, look, if you don't give me a share of the airdrop, I won't include your transaction, right? So then, okay, after all, there might be some MEV character to this extortion capability of the coordinator, right? And this might look like a very contorted example. Okay, after all, is there any airdrop that is only valid for one block? But if you think like a little bit deeper on this, and if you do some numbers, you can think of the earlier Ether transfer, and from the earlier slide, and there, if you have a collusion of, say, 10% of the validators, they could, in principle, extort you for 0.4% of the value. Shin has run these calculations, right? So 0.4% of the value is a lot, right? It's more or less the same as the fees that you pay like swapping on Uniswap or whatever. So actually, this example, again, that looks contorted, is not and could very well happen, right? So extortion is a real thing. Okay, that's again for the left side. On the right side, this is not too interesting. We have the example I gave you earlier of the dollar bill. You pick up a dollar bill, that's permissionless value, and that's arguably not MEV. But okay, that's an example that's outside of the blockchain. So perhaps we want to consider permissionless value on the blockchain. How this set of things. Okay, the two examples I gave you for the intersection and for the MEV side are on the blockchain, so we know this exists in principle. So how about the other side? Are there things that are permissionless value on the blockchain that are not MEV? This is a question for you, actually. I haven't found an example, so if you can come up with an example, again, of things that are permissionless value on the blockchain that you wouldn't call MEV, please let me know, and we can sort out that set inclusion there. So this is a one candidate set to consider for characterizing or half characterizing MEV, if you will. Okay, thanks for bearing with me. We've been through a lot of Venn diagrams. This is the last one. Okay, how about value extractable by a monopolistic coordinator? Again, I've argued for the importance of a coordinator because it changes the game theory. It makes it more fun. So here again, critically, the coordinator needs to be able to extract for that game theory to be richer. And it has to be monopolistic because also for the extortion I showed you before, if it's not monopolistic, then this doesn't work. So in the intersection, we have the same example as before. Arbitrage is an example of this. Monopolistic coordinators come like naturally in blockchains, like the proposers are that, right? Okay, so how about the left side? Are things that are MEV and that are not value extractable by a monopolistic coordinator? And here it depends on your earlier choice on the Arbitrum example, right? The front-running example. Okay, if you decided to call Arbitrum, ARBs, that type of front-running MEV, then this is an example of an element here, right? Because it's not value extractable by a monopolistic coordinator, but you're still choosing to call it MEV. Again, a choice. Finally, let's look at the other side. Is there value extractable by a monopolistic coordinator that is not MEV? Can you find examples of this? I haven't, so again, challenge to you all. Please come talk to me if you find an example in this set there. And again, we can sort out this question here. Okay, so we've dealt with the concept of MEV. We came up with three sets that look like might always be MEV. This is, of course, not a full characterization. Just to sum up, value extractable by a monopolistic coordinator, front-running, permissionless value on the blockchain. This is quite an unfortunate picture, I would argue, right? Because there's these three disjoint sets, and how are they related to each other? This doesn't look like a unified theory of MEV, right? One would ideally like to have a more concise idea of what MEV is, right? And these are only, if at all, partial characterizations. So what comes in the talk that comes next, Shin is going to share a little bit of that and try to come up with, this was more like an outside-in exploration of the idea of MEV. Shin is going to share an inside-out, a more constructive way to think cohesively about MEV. So again, thank you so much for coming. Appreciate you all being here. And yeah, I will pass it on to Shin, and then we can do questions together.
Thank you, Alejo. We have a huge line over there, so we have a problem. I mean, in terms of fairness, I know I asked, and the only one was Mr. Paladino.
Is this MEV?
How can we solve this? Do we have volunteers to let some people to participate. We can do a.
This is not. This is not MEV.
Let's try to fit at least 8 more. Do you think we can make it? Maybe that's where we can do some sacrifice in terms of comfort and let 8 people to get in. So, Andrés, 8 personas. Here,
Chris makes it.
so,
Oh, cost what? That looks so bad. Yeah, Arbitrum is not the.
Are the Arbitrum people around?
No, I don't see Arbitrum. He's probably further down the line. You can see speaker notes, right? I heard Arbitrum
Here we have some
included my
room.
post. Anyway.
Okay, extra share over there. Thank you so much. Thank you for sacrifice for the team. Okay. Maybe 2 more can fit up there. All right, so next to the stage.
Okay.
Shin?
Okay.
Do I have
Alejo has the.
Yeah. Okay. Yeah. Oh, the clicker. No, it's up there.
Oh, it's up there.
But okay. Listo. Bien. No sé, tengo que pensarlo bien, pero ahí el proposer sigue teniendo el poder.
Can I start?
No sé si estoy saliendo por el.
Point to that corner of the.
What?
Let me show you.
Okay.
Okay.
Ahora me lo explicas bien, pero estoy todavía.
All right, big round of applause for our next speaker.
Woo! Yeah, so from the last talk, we arrive at this slide and having a test for non-MEV needs. But in this talk, I'm done talk about, sorry, but this formulation of MEV is mid. So specifically what it means, why? Because it's like a party guy, a guy at the corner of a party saying they don't know this is not MEV, while the other people, all of us, are like, yes, we know, and we don't care. It's a good meme, and it's, memes are important. Memes are more important than, arguably many other things in our life. And then, but there is also another extreme in the community vouching for a formalization of MEV, right? So some common pitfalls on this, on the definition of the word MEV is that we give up on the clarity of the notion, we over-formalize it such that we lose the memes, right? It is no longer a meme term, and it's lost in, and we are getting lost in the detail of the real value of defining MEV. So in this talk, I will give a clear definition of MEV that points to a solution, 2 points clearly to the solution recipes that how we should solve MEV. And I'm not gonna give a mid-curve formalization, nor am I abandoning our memes. So what is MEV? So by the end of the talk, you will see that MEV is Al Capone, Evil Deity, and Louis XVI. So this is MEV. Yeah, so to start, we see that, so why Al Capone, the mafia, is MEV? So because mafia extractable value, fits the M, arises when one agent or a coalition of agents gains an asymmetric knowledge of another agent's private information. So this condition on there exists an asymmetric sophistication between agents. So very easy examples include sandwiching, journalist front running, or in traditional finance, we see that people trading, one strategy is that people trading on the limited order books imbalance. So which is essentially a form of one agent gaining knowledge of another agent's utility or intent, right? When you see more bid than ask on the book, then you take the best ask and you make the best bid. So then evil data is a malloc YZ MEV. So malloc extractable value is a value that was surrendered to the malloc, i.e. on coordination within your mechanism, your allocation mechanisms for people's preferences. So one example of this is the negative externalities caused by inexpressive mechanisms. So for example, suppose you have a random ordering, then people spam the network, and that is the only way they can express their preferences, and it is very one-dimensional way, right? So you have a kind of a shrink transaction quality trilemma. And there are, of course, many other examples. For example, in the traditional high-frequency trading arms race example, the cost that market maker spends on arms race gaining latency advantages was channeled as charging higher spreads for users. So the externality is transferred from sophisticated agents to unsophisticated agents. There are some other examples. And so finally, Louis XVI, the monarch, why is him MEV? So monarch extractable value arises from the fact that the coordinator, so for example, the sequencer or the validator has the ultimate power of deciding what the ordering or the allocation of specification on state is. So by specification on state, I specifically mean which specification or property does the next state satisfy. You can, for those of you familiar with programming languages, you can see that this directly links into the formal verification. You have a program and the specification that the next state must satisfy. So then some examples of this include that the validators currently, in Ethereum or other chains, accrue value because they have the power of determining what content is in the block. And many other examples for in TradFi, such as colocation fees, and cross-chain, such as cross-domain market makers for swaps. So then we can see that MEV arises from three distinct properties: the mafia, the malloc, and the monarch. So now a little bit more formalized. Suppose that M is the monarch in our universe or our game E, and W is the social welfare function. Then we know that the malloc extractable value equals to the welfare that is achievable by the best possible mechanism for our game to allocate specification on state minus the welfare of the current monarch. And the monarch EV equals to the welfare of the current monarch minus the welfare that already existed, in the original game E without our current monarch as a coordinator. So you can see those are closely tied to the idea of externalities, right? And then from our definition, we know immediately that monarch EV plus malloc extractable value equals the welfare of the best possible mechanism in our game minus the welfare of the original game. So it equals a constant, right? So the malloc EV plus monarch EV is innate to the game E and does not depend on our choice of the mechanism M. And finally, defining mafia EV is a little bit harder, but the intuition is that mafia EV depends on the specific sophistication details or the power of agents that is existent in M. So what this means is that how much exposed knowledge or last look one agent can have over other agents or their coalitions. So then we can see that those three values have distinct sources, and those sources of value are non-overlapping. Thus, we can call them, our new definition collectively 3 EV: mafia, malloc, monarch, extractable value. It forms a sum type. It's perfection. So then what this implies is that the solution recipe, right? The future is in our hands. We know that mafia plus malloc plus monarch is 100% of the MEV, and that monarch EV plus malloc EV equals to a constant depending only on the original game. But the percentage of malloc versus monarch depends on M, our choice of the mechanism. So you can already see that there is a nice link with the notion of price of anarchy in traditional mechanism design here, right? Although in traditional mechanism design, of course, like there are theorists they want bonds, so they have they define price of anarchy as like the division, but now we are interested in values, so I kind of define it as difference. And then finally, we can see that Mafia EV is also a constant depending on our choice of M. So since the sources are distinct, we can adjust the percentage of the 3 variants of MEV by transforming one form of MEV into another in our designing of a better mechanism M. So I argue that ideally we should have 0% Mafia, 0% Malloc, and 100% Monarch, where the Monarch's profits are distributed. So what this specifically means and why is this true is that because Mafia relies on the existence that there is one ex post knowledge and there's unsophistication or sophistication between agents, right? There is an asymmetry. And so specifically, once you have this, then the sophisticated agents are going to charge sort of an unsophistication tax on the other agents, and thus this hurts long-term stability of the domain or long-term prosperity. And then why we want 0% Malloc is because any value that, or any welfare that is tributed to the Malloc is forever lost, it's not recoverable, and nor is it redistributable. So then, and why 100% Monarch with redistribution is that if there is no redistribution to the Monarch, then the 100% Monarch EV is going to erode the incentive for people to use your mechanism, right? Because you're essentially creating, reintroducing the value that they would have paid to the Malloc by having them pay to the Monarch instead. So there's a different, you can see there's, so users would be indifferent between paying to the Malloc in the original game and paying to the Monarch in the meta game. So this kind of violates the individual rationality guarantees. So then there are, of course, some caveats as to our choice of Monarch and our definition. So as we can see that the welfare of the game without the mechanism depends on E, right? So now we assume that the mechanism M represents a domain or a builder or just some coalition of agents. Then we can give a kind of have a notion of inter-domain correlation factor K, where K equals 1 if the mechanism is monopolistic across all domains. So here we are kind of cheating a bit. We are including time as another domain. So K is kind of like a discounted n-dimensional preference curve. And an example of the preference curve you can see on the top right corner. And then K equals 0 if the mechanism is powerless. So then what this implies is that by forming a larger coalition means the coalition has a higher K, and this enables them to do more credible extortions. So what this means is that the Monarch extractable value for your coalition of agents, forming the mechanism M equals to K multiplied by the original Monarch if M and minus M forms the grand coalition. So then, of course, this implies the users can also be the Monarch if they have a large enough K, right? And similar for validator searchers or builders, you can imagine different mechanisms than what is currently being played in the MEV field. So essentially, the interdomain correlation factor represents your collective bargaining power, which determines how the Monarch is set up, who we throne as the king, and how the Monarch is set up within the game. So then, however, okay, so there are some caveats to the choice. How much coalitions can you have, right? So you can imagine this formalized as a core of the game, where the core of the game might not exist if we have too many inter-domain coalitions. So this kind of reminds us as the original notion of there exists a non-monotonicity of coordination and efficiency, and this also relates back to a notion I would like to call the incompleteness theorem of MEV, right? So you can see that the game E cannot continue if there is not enough competition. What this means is that you can increase the coordination, but it does not always increase the efficiency of the allocation in reality. And even if you try to eliminate the inefficiencies caused by your extra coordination by using another credible commitment or coordination device in the meta game, then you're just transferring the Malloc extractable value in the original game to the Monarch in the wrapped game, right? So this kind of provides a ground for us to refute any, previous ideas by Virgil Griffiths and his whole Ethereum as game-changing technology argument. So then coming back to this, the specific value of the correlation factor K depends on how we set up the game. We can throne or dethrone different monarchs. Ultimately, we want to choose the best mechanism M star that is most incentive aligned with the long-term prosperity and is most capable of coordination. So you can see there's a trade-off over here. And of course, like, why do we want a monarch? Why do we need this meme, right? Why can't we just go the formalization route, full formalization, throw in math equations? So the reason for this monarchy abstraction is because the outcome in contrary to traditional mechanisms, the outcome in MEV is not common knowledge and depends on each agent's private information, which the other agents don't have prior to the MEV time, which is the allocation time or like block building time. So it is hard to analyze the equilibrium within this game, especially when there exists an asymmetry in the sophistication of agents. So thus, we reduce the guarantee of our mechanism to just have some bounds, like some loose bounds on the incentive compatibility and the individual rationale. So then, now to concretize things, we provide some case studies. So specifically, we say that there's we know that there has been vanilla first come first serve and a frequent batch auction style first come first serve, where we increase the fairness granularity within the receive order fairness protocol. So what this specifically means is that instead of reporting a strict ordering by the receive order time of the transaction, each individual node now reports a partial ordering to the leader of the ordering consensus protocol. So what this concretely means is that you just take the smaller than to smaller or equal to. And then after aggregating each individual node's preference, the monarch, in this case the leader of the consensus protocol, gets a weak ordering by first come first serve. And then of course we know there must exist some unordered batches in it, which is caused both by the Condorcet paradoxes and the initial partial ordering reported by each individual node. So now the monarch tries to resolve the order of the unordered batches using auctions, right? So this is why it's frequent batch auction. And then in reality, why is this more reliable? Like, let's peek into some data. We see that in reality, it's over 65% of the Uniswap volume comes from arbitrage, maybe statistical. And among the other 35%, it's a few market makers. So what this means is that the MEV activity constitutes a huge amount of Ethereum activity. And the burst period on Ethereum, which arises from public information reviews, so for example, some price discoveries happens on Binance, or some people, some whales send an unprotected transaction into the public mempool. Then once this kind of event happens, it takes around 1.2 seconds, and 75% of the conflict of preferences on Ethereum, conflict preferences, meaning that there is a conflict within what specification should the next state satisfy. It happens less than 4% of the time. And so this means that vanilla first come first serve compared with frequent batch auction first come first serve will be bearing the extra negative externalities, which cause worse UX, higher fees for users, or centralization in the nodes from 12x more conflict of preferences. So bursts of periods of preferences are significant, and just adding some partial ordering, just covering that little 4% window, you can mitigate most of the negative externalities on the domain. You can take value back from the malloc, right? So if we use the 3EV framework to compare those two protocols, we can see that they have the same mafia, right? And for malloc, the vanilla version has much more malloc, because the vanilla version, nobody can express their preferences in a short burst period, which constitutes most of the activity, right? So the malloc arises from, the tribute to the malloc arises from uncoordination, and an ultra simplified social choice function, right? Where the social choice function is like I choose the preference by the order I receive them. That does not coordinate any of the burst period MEV, right? And the burst period MEV, typical cases include like permissionless MEV, price discovery, atomic MEV. So and then so you can see from the graph on the right, right? Like we are transforming the mafia slowly into the malloc, where the value is transferred to the users, so the users have the same payoff. same bad payoff. And then for the monarch, it's strictly worse, right? By our definition, but also vanilla versions run the wrong monarch, right? So in latency games, you pay more to AWS or Google Cloud because you need to play the latency games, and thus the monarch, Google and Amazon are obviously not incentive aligned with crypto or like whichever domain you adopt your Arbitrum protocol on. And of course, it's more centralized because, come on, it's like fan. Okay, so now some concrete examples. Let's see, transformation of 3EV. Does 3EV actually capture most of the existing MEV notions that we have? So for transferring malloc to monarch, we see that one form of this is the spread charged by market maker bridges. From monarch to mafia, we see that if in previous Ethereum proof of work, the miners were to go rogue and steal bundles, then it would be, they were the monarch, but they choose to gain an advantage using the asymmetric information and ability to act on that information. Wait, what? Okay, and then from mafia to malloc, the transformation. So for example, you go from a public mempool model to a vanilla first come first serve, right? You eliminated public mempool, so you don't have that information asymmetry, but you have that, on coordination, you have a very bad allocation of preferences. Which increases malloc. And then from malloc to mafia, you see that, so for example, if a malicious coordinator were to pocket all of the surplus welfare that it generates from optimizing the ordering or just existing, from coordination. So this case, you go from, malloc to mafia. And then what we can do to go from mafia to monarch is to have programmable privacy, right? So in this case, for example, SGX, you can still do bundle merging or block building or preference segregation, despite that you don't have asymmetry in the information And then finally, come on, the current model of DAO governance is a form of transforming the monarch to the malloc, which is not good, right? So, so what this means is that so DAO exists for coordination, right? But then by launching a DAO token and then allowing it to distribute under a bad tokenomics or like whatever, you're creating a Ponzi which creates more malloc, right? You could have got that to a monarch stage, but then through more decentralization, you have recreated the malloc in the meta game of the token game, right? So this reminds us of the previous example of the non-monotonic relation between decentralization and coordination and efficiency in the mechanism. So then some implications of 3EV, right, concretize this idea. Why is it useful? So then the solution recipe is how to achieve 0%, 0%, and distribute to 100%. We can solve Mafia EV using programmable privacy, which allows for expressivity and agents can control how their information is used along the path of the determination of the outcome by the monarch. Also, this relates to the traditional mechanism design's idea of the definition of how expressive a mechanism is, right? And then concretely, what this means is that you can devise a mechanism for discovering the unsophisticated user's preferences and helping them to communicate this preference to the coordinator or to the mechanism. And then we can solve malloc extractable value by just increasing more efficiency, right? We can eliminate the price of energy via refinement of society, or i.e. specialization of labor. So what you can see, in this example is like contrary to the idea of malloc, you have the idea of a slack, right? So slack arises from coordination where it's basically you allow somebody to have enough mode or like period where they can grind on the higher payoff scene. And this is only allowed if you have a highly coordinated, specialization of labor in your society. And then finally, monarch extractable value. How do we division its value, right? So the value division, we should division it in such a way in that we maximize the welfare or the future returns. So what this means is that you probably shouldn't focus on giving tiny kickbacks to the existing 1% of users, but instead focusing on onboarding the invisible 99% of users as monarch extractable value or like MEV in general grows super linearly with respect of compare with the number of order flows that's existent on your domain, right? So for example, the ways you can do this is through investment into wallets or some idea like retroactive public goods funding. And of course, this was the original idea by fair ordering as well, right? Like the idea is that you can, there are 99% of users that would have come to your domain if you order things, fairly. But so it's been on as a narrative. And then, so then specific implementations, we know that 3EV was defined by the source of value, right? They are distinct. So the sink, however, the sink of those values are different. So for example, the mafia extractor value sometimes sinks into monarch, right? So for example, when there is a sandwich and then two very competent atomic searchers, the value sinks to the monarch, which is the validators. And then the sink of value impacts the source of value. So I argue that by controlling the sink of the value, we can also impact on the source of the value by the magic of credible commitments. So some example of credible commitments, I'm not gonna explain, but you can hit me up later after this talk. Examples include builders as rollup, or you have a special builder innovation where you grind on the expressivity of the building language, or you have a decentralization of building, use SGX tokens to align the incentives, or some more fancy things. But all of those conditions on, all of those solutions conditions on a low enough interdomain correlation factor, right? Remember from before, once you have too much correlation or too much coordination, then you can't possibly have a good mechanism, or it's very hard to do so. So and that a low enough factor means that you have high enough competition, which means the market is contestable. So I claim that having more competition in the game, by incentivizing having more competition in the game, is right curve behavior, and optimizing the ordering by learning more about the preference microstructures and then grinding on the design of the mechanism is mid curve. So contestability is an important tool, and it can only be realized if we design the initial market in such a way that it is not centralizing. What this means is that in reality, what this means is that there should not, we should definitely devise a mechanism that where exclusive order flow wouldn't exist. So then, finally, I would like to provide some philosophical foundations for the previous talk. Right? I said it's mid. Now it's time to show some real work, show some real test for non-MEVness. So then remember that Frege and Russell was debating why, whether the king of French was bold, right, in the beginning of 20th century. And they come up with the tests for presuppositions for utterances of sentences. So for example, the utterance of the sentence axis MEV has a presupposition test that there must exist a game E and an allocation or ordering protocol M, and that within M and E, using the 3EV definitions, we can indeed see that M is constituted by a type or multiple types of the 3EV. So in this sense, the utterance of X is MEV has a presupposition of the existence condition of E and M, and X being indeed in the set of 3EV. Thus, if there does not exist such a E and M, which translates into English is that if there is absence of a monarch, then the utterance of this sentence, X is MEV, is false, and X is not MEV. So then some concrete example, imagine Kim and Dong are playing a prisoner's dilemma, right? So then they both choose to betray. Now suppose there isn't a coordinator, okay. So then somebody utters the sentence, he says that the value that Kim and Dong is extracting absent a monarch, i.e. 1, is not MEV, then this value is indeed not MEV by passing the presupposition test, right? If we take a free game view. And then, of course, there are counterexamples. Like Wittgenstein has this notion of a language game where the context depends on social things. So the utterance of axis MEV, so this sentence might be true as the context of the utterance is social, and we might agree on some notion of the game. So if the sentence is provided without context, then the sentence is nonsense and has no truth value. Thus, ultimately, the test of MEV conditions on which philosophical interpretation of language you agree with. If you are Wittgenstein, you're with Wittgenstein and believes that the utterance is within the context where it is socially agreeable that a monarch exists. So in the previous rugby case, remember, we often say that physics is the monarch, and then over there the value is indeed MEV. Okay, so now some takeaways. Let's change the language game. Aren't you tired about minor or maximal, where the grammar isn't even correct? Like we say maximal MEV all the time, and we should just say MEV, and it conveniently represents a shorthand for some type of mafia, malloc, monarch extractable value, right? Have you been saying MEV because you have poor imagination to come up with a replacement term for minor that keeps the M and makes sense? You know, is that what we're doing? You know. So then the argument is that by changing this language game, we have several benefits. We have, this formulation gives you a distinct value, which originates from the source, and then it is more formalizable, and it is formalizable in the sense that you don't get lost in the details. It is still keeps the meme, and the formalization and the proof only serves as a social process to help people to understand it. And then, of course, this settles the bad MEV argument, and the trade-off or the transformation between the three value space is clear. What this implies, this implies a clear solution recipe. So some nerd sniping for you all is that to research on how monarch extractable value can be distributed and research on the programmable privacy solutions for mafia EV. And then finally, a presupposition test. And so to conclude, I would like to hypnotize you. 3EV, 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 3EV. That's all. You can hit me up.
Well, I think we all agree that was a fantastic talk. A lot of like the two speakers. We said at the beginning that maybe we have time for questions. So let's pick a couple of them. Over there, it's going to be hard for me to get there, so maybe you can shout out aloud.
Yeah, good question. So OFAC censorship can be done implicitly using a term, using a form of the preference curves, but Alejo maybe.
Is it monarch? Is it mafia? Or is it Moloch MEV?
It is monarch. Yeah, but as I said, like what we want is to shift the structure of the game, right? Remember the interdomain correlation factor. You can unify the users by devising some mechanism to help them become sophisticated and have collective bargaining power. So that is what we ultimately want to do. Yeah.
Anyone else? All right, guys. So big round of applause for this amazing talk.
Okay, and I have more writings on this. DM or talk to me.
Danny.
Yeah.
Yeah. I am moving to New York, but yes, I'm still moving around a lot. UNSF?
Yes, I think I'll be there for another 5 years.
I'll come to California. I'll let you know. Are you giving me a cookie?
Jessica is our DevRel at
Nice to meet you. It was pretty crowded. Gracias. Señor.
I'll sit down for next time.
Good.
Tal vez él es el que va a ser moderador, se llama Ian. A ver, pongámosle. Que va a estar moderando. Y los que están, las speakers,
¿Quién va a ser el moderador? El señor del gringo. Yep. I guess water would be great if you have some. Thanks. Are you Ariel?
Yeah.
Hi. Good to meet you, Mike. Yeah. We don't really have a particular order, so you can sit next to whoever you like the most or the least, or up to you. Oops. What's that? Yes, yeah. Hey, Vasily. We're going to meet over here and walk on up. So we have a microphone for you.
Okay. Hello again.
I think we'd have a microphone.
Yeah.
There's one.
Got some?
5 more.
Oh, thank you.
Good afternoon.
Gracias.
There is room right here. If you want to sit down, front row, there's going to be 50 minutes panel. We're going to start in about 2 minutes.
Hey. Presentation is set, so just let's go to the stage.
All right. Is everybody ready? Okay.
All right. So we are about to start. There's going to be a panel. 50 minutes. Are we going to have questions?
Yes.
How do you want to lay down the dynamic?
So we will have first a couple questions for everybody to answer individually, and then we're going to do some questions. They're more discussion questions, and then hopefully we'll have some time at the end for audience questions.
Perfect. So please, a big round of applause for our speakers.
Hello, everybody. Thank you for coming out. This is in case you don't know where you are, this is staking panel with all of the most prominent protocols on the Ethereum network. So we're going to have a great conversation today. I'm excited to talk about the state of Ethereum staking right now and where we think we're going to go for the future. So the topic for this panel is sort of loosely centered around the idea of promoting small and independent stakers. And if you're asking yourself right now, why do we care about that? Why don't we just let Coinbase do everything? Well, hopefully you already know the answer, but I'll answer it anyway. It's healthier for Ethereum to have more people involved, especially smaller and more independent actors, so that we can all sort of participate in a healthy Ethereum together. So today, one of the things that we want to find out is how we can promote more small and independent stakers on Ethereum. Before we do that, let's get into who each of these people are on stage. Hello, everybody. I'm Mike, and you may know me as Wander. I have been part of the journey of the Node Operator Association, a community organization to promote professional node operators. That's anyone on the Ethereum network who stakes for a living, or especially those people who like to take outside investment into their staking operations. Our goal as an organization is to try and promote this nascent industry as much as possible. I'm also the founder of one of those kinds of organizations, of course. Bamboo Financial Technologies does staking on Ethereum for our customers, high net worth individuals and institutions looking to get involved with Ethereum staking. So let's meet our panelists. First up, we have Ariel. Sitting next to him is Vasily, and next to him is Oshin. Then we have Darren and Jordan. So while we have you guys here on this panel for just a second on this slide, would you do me a quick favor and introduce yourselves and your protocol? We'll go ahead and start with you, Ariel.
Hey everyone, my name is Ariel. I work at Blocks, which is the company which is the core developer of the project SSV Network, which provides a decentralized infrastructure for Ethereum staking. For those of you who doesn't know us, SSV stands for Secret Shared Validators. It's an implementation of DVT, Distributed Validator Technology, and it was built to be used as the building blocks for high performance, secure, and decentralized staking applications on Ethereum.
Thanks.
Hey, I'm Vasily. I'm from Lido. It's a DAO that builds liquid staking protocols. The flagman protocol is Lido on Ethereum that currently operates about $6 billion, a bit more, and like that's the most important thing we do.
Sweet. Hello everyone. My name is Oshin, and I'm co-founder at Obol Labs. Obol is building the Obol network, and it is building distributed validator technology to allow high uptime validators and validators run by multiple people collaboratively. Thanks.
So I'm Darren. I work on Rocket Pool. Rocket Pool is a decentralized liquid staking platform. We have a liquid staking token called RETH. I guess what makes us kind of unique is that we have a permissionless validator set, so anyone can be a node operator in Rocket Pool. That's it.
Hey everyone, I'm Jordan Sutcliffe. I'm the business development lead at Stakewise. Stakewise, we're also a liquid staking pool. Not quite as big as Lido. We've currently got about 80,000 ETH staked with us. And yeah, we'll, one of our key goal is to help reduce the barriers to entry for people to stake on Ethereum. And there's also a pretty exciting roadmap in place to go permissionless too, which I'm sure will come up in a bit.
Absolutely. Thanks so much, guys. Appreciate it. All right, so now that we've heard a little bit from all of our panelists who know who we are, let's get to know the platforms they represent on a more detailed basis. So the first questions, like I mentioned before, are going to be for each panelist to answer individually, and then we'll get into some discussion questions after that we can kind of go a little bit more freeform. So our first question here is, it's actually, I've written 3 on here, but that the top one is sort of the real question. How does your protocol promote independent validators on Ethereum? So Ariel, I'll start with you.
Yeah, so first of all, as the infrastructure for staking application, like that's the way we support the next wave of those staking applications, which will attract more independent validators and operators. Our platform is completely permissionless, so anyone can join. The requirement is only to run a node. It comes along the standard nodes, the execution and consensus that you have to run. And we have a lot of resources available, a lot of guides. We have a big developer community who can help you out with anything you need. Very easy and simple to set up.
Yeah, so at Lido, we run a validator set of professional operators that is regularly expanded at the current time. We are working on a solution for us to allow us to onboard independent validators, which is not quite as easy as it is for different models of staking, because we do a liquid staking token, and we do it without requiring operators to have a bond for the risk. We have to manage risk in different ways, and it's very hard to do with permissionless mode. I think we'll get there, but we are not there yet.
Sweet. On the Obol front, we're implemented maybe slightly differently than some of the existing pools. You add our software into your stack and you run it with the other operators you want. You either run it on your own or with like multiple other operators you want to run a validator with. But generally speaking, it's permissionless and there's a launchpad that you can go on and set up your validator and create it with your counterparties as you wish. There's no restriction to get involved effectively.
So the answer to the question, are we actively recruiting? This is a resounding yes, 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 yes. We have like a deposit pool full of ETH that is waiting to be matched with new node operators. And we are actually bringing on new node operators very, very quickly, but we need more and more. So as said, Rocket Pool is permissionless. We have about 2% of the Ethereum stake at the moment, but we're growing very, very fast. We've got it over about 1,600 node operators so far, and we're getting kind of more and more each day. It's quite interesting seeing the stats. It goes up quite quickly. But yes, we are recruiting.
So Stakewise in its current form runs a validator set similar to how Lido does, where we have our DAO approves a set of node operators for the network. But we've just announced our plans to launch a fully permissionless platform in December this year, where we, a couple of people have hinted on the requirement for collateral requirements for node operators. So the plan for Stakewise is to allow anybody to join the network in a fully permissionless fashion without any collateral requirements. And so for this, we've had to design a novel staking mechanism that basically ensures that we can provide a liquid staking token that still has slashing protection despite the lack of collateral requirements for node operators. So are we recruiting new node operators? We damn well definitely will be in December.
Excellent, excellent. It's great to hear. These are 5 of the most prominent Ethereum staking protocols on top of the basic protocol, and all of them are looking to move towards permissionlessness and onboard new operators. So if anyone out there is thinking about running an Ethereum validator, you have lots of options. So let's get into some of the costs and benefits of each individual model. There's been some allusions so far to the differences between each of these protocols. Each of them has a different design for how they've decided to set up their protocol, and there are some trade-offs and there are some advantages to each of these. So I'll go ahead and read this slide. I should have read the last one too, but we'll go ahead. First, what revenue can node operators expect in your platform? Especially, it would be really great to describe anything above and beyond the typical Ethereum staking revenue. Where that comes from especially would be really nice to know. Another one, what are the risks on the other side of that operating a node with this protocol entail? So, the audience is almost certainly going to be thinking in the back of their heads, what are my risk-adjusted best options here? Can I take on more risk to get more return? How does that work? And the final question here on the same topic, why should node operators choose your platform ultimately at the end of the day? And this is where we get a little bit of a competition going on, so sorry guys. But we'll go ahead and as is tradition, we'll start with you, Ariel.
Yeah, so our network is permissionless, and also it's a free market. So the operators choose their own fees. And we are also non-custodial, so that fee does not come from any rewards of the stakers. It comes in the form of SSV tokens that they pay on top of basically on top of nothing, just for the operation. So the revenue they can expect is whatever they choose to charge. What are the risks of operating a node? I'll answer this differently. The current risks that most staking providers have are highly mitigated through DVT. Because you have fault tolerance, you have more security, no one skips the keys online, you only have shares of it. So there's no really single point of failure. So a lot of the things you have to do around to mitigate or reduce the associated risk are very much lowered once you use a DVT-based solution. Why should you choose us? First and foremost, because it's gonna help decentralize Ethereum, right? And because of the mechanism which each validator in our system is distributed between a lot of different operators, meaning for each staker he has to choose multiple of them, it kind of gives you a lot of more revenue, a new revenue stream, right? Because there's a new channel to be chosen by others that need to validate their to operate their validators. Yeah, I think that's about it.
Thanks. Yeah, so in Lido, we have currently 28 node operators, and we expand that number when we get more stake in a way that no node operator in Lido has like a big share of stake. We try to keep it like less than 1% of all of them staked, but no, it's around like the highest number is around 1.5% or so. And they should have enough stake for it to be a good business to work with Lido. So we're talking about 1,000 operators, 1,000 validators or so, which makes it like a good deal for another operator to run in Lido. That's the current setup, and the selection is done by peer review. So like we basically ask the existing node operators for Lido, like 28 of them, to rate the people who leave the who want to participate in Lido. The risks of working Lido is mostly reputational. Like if you screw up, like that's going to be very much known, and you won't get more stake from Lido or like from many other sources of stake potential.
See, on the Obol front, rather than talking about what revenue you can make on top of base, I might instead look at where you might be able to save money as an operator. With Obol and distributed validators, the two ways you can do it is you can take part in some other distributed validator, or you can control all of it yourself in like 4 different availability zones or something. But generally speaking, if you have a fault-tolerant validator, first off, your DevOps risk is much lower because you're not waking them up in the middle of the night every time a server dies. They can deal with it in office hours. Separately, on the hardware side, most people keep a small amount of validator keys per machine because when you go offline, there's very little you can do about it. If you have fault tolerance, you can safely kind of start to lift those numbers. And then the last one is if you're running validators with a group and you don't have total custody over it, your staking or your slashing insurance costs we're hoping to come way down, because the worst case scenario here is if you're compromised, the other 3 people have to go and like recreate a new key for you, but the validators don't get slashed, the validators don't go offline. So the risks are a bit different, but hopefully, lower like net with DVT.
So in terms of what with revenue, so each Rocket Pool node operator brings their own collateral with them. Proof of stake is called proof of stake for a reason. There has to be something at stake. So they bring collateral with them. Now, in terms of revenue, they actually earn the base Ethereum fee for their 16 ETH. But then we match them with 16 ETH from liquid stakers. And they actually earn an extra commission on the 16 ETH that they stake for the pool. So they get 15% of the rewards they generate for the pool. So they get kind of more than you would if you were a solo staker. Plus you need less ETH, because you only need 16 ETH, you don't need 32. We're looking at lowering that in the very near future as well. So in terms of risks, there's slight bit of smart contract risk with Rocket Pool because we're a decentralized protocol. Everything is trustless in the sense that node operators don't take custody of funds or anything like that from liquid stakers, so we have to go use smart contracts to do that. But we have been audited by the best in the business. When I say audited, I mean like tons of times, like 4 or 5 times. So every release we do, we get multiple audits, and so we're very conscious of that. Other risks in terms of like performance risk. So if you're slashed, it does come out of your bond, not our ETH stakers. But Ethereum is actually a very forgiving protocol. It's very unlikely that you get slashed, and there's kind of pretty much one reason why you get slashed. And clients, consensus clients, have actually built in protections for that. So if you're offline, it doesn't actually matter that much. you can be offline and you'll earn that money back very, very quickly. So yeah, so that's the kind of the risks. Why you should choose us if you love Ethereum. You should probably come with Rocket Pool. But also we have a fantastic community. That's actually one of the things that I love about Rocket Pool, is that you come into our Discord and it's an absolutely amazing community of people who are passionate about securing Ethereum.
Awesome. I'm probably going to answer this in reverse. So we designed Stakewise v3 to help decentralize Ethereum. And the key target audience, well, one of the key target audience for Stakewise v3 are solo stakers. So what are the current issues with solo stakers? These guys and girls are the gold standard for decentralization on Ethereum, but their ETH is locked away. They do not get the benefits of liquid staking. And it's no surprise that the most popular platforms and the majority of inflows into staking over the past year have been with liquid staking providers. You're allowed to unlock your capital to use within DeFi. You can unstake all or at least a portion of your capital instantly. And this is something which solo stakers have missed out on. And so with Stakewise v3, solo stakers will be able to move their nodes over to Stakewise and be able to mint the liquid staking token off their nodes. So this gives solo stakers, the idea here is just to make solo staking attractive again. You guys can get, it basically solves the capital efficiency issue for solo staking. On top of that, you'll also be able to accept ETH delegations from others. So for example, maybe you've got enough ETH to run 1 or 2 validators yourselves, but your infrastructure, your PC you're running these validators on could actually run hundreds. And so with Stakewise v3, you'll be able to get anybody depositing ETH into your mini staking pool, and you'll be able to spin up multiple validators. And so not only will you get better capital efficiency, you can mint a liquid staking token from your own ETH staked, you'll also be able to earn revenues from staking ETH of others and maximize the potential from your infrastructure. So yeah, touched on the revenues part there. The plan is for 100% of the revenues on the ETH staked from other people to go to the node operators themselves. So it's similar to your system. And I guess the risks, so one of the risks, if you're looking to ramp up your the amount of ETH you're staking for yourself, but also the people, one of the biggest risks is that you're just not attractive to other people to stake with you. And so we've designed a system, we've designed like an operator scoring system where node operators which have high quality, whether it's proven on-chain historical performance, whether they do post some collateral or do have some slashing insurance in place, whether they help contribute to the diversity of ETH staking in terms of geography and client diversity, then these node operators will be rewarded by having a higher operator score, which will attract further capital. So again, we're trying to build a system which encourages decentralization, and there's a couple of ways which we can control or push decentralization through the Stakewise v3 infrastructure.
Great, thanks so much. Go for it.
I missed one important revenue, and they'll kill me if I don't.
Okay.
So the other revenue stream that you get with Rocket Pool is that you stake RPL, which is our native token, with the ETH, and for doing that, you also get RPL emissions as well. So RPL inflates by 5% per year, and 70% of that goes back to node operators. So node operators kind of get like this this RPL kind of interest as well.
Got it, thanks. All right. So now that we've gotten to know our Ethereum staking protocols a little bit better, let's get into a little bit of a panel discussion about the future of Ethereum staking and where they want to take the future of their protocols, where they see Ethereum going, and how this whole thing is going to evolve in the long run. One of the questions that I have as a node operator myself is, what happens to my stake in 5 years? What about 10 years? What is my returns going to look like? Are they going to be lower? Who out there in the world is going to be staking on Ethereum? Is it just me? All these questions and more, I'm sure, are popping into the heads of the audience out there if you're a node operator. So these questions are going to be a little open-ended, so anyone can answer. If no one does, I'll just pick somebody. So that's your threat. But hopefully we'll get some interesting discussions going about the future of staking. All right, first up, so the first questions we have is revolving around the distribution of staked Ethereum. What do you all think the future of staked ETH looks like on the chain? How much will be staked out of the overall, and who will be doing that? Who wants to take this one?
Yeah, I can.
All right.
Yeah. So like we have actually like a very strong thesis around that, around which we built Lido. I think that like most of like about 60-70% of Lido will be staked, and most of this will be staked in liquid staking, and most of this stake in liquid staking will be in protocol-based liquid staking, not exchange-based liquid staking or something like that. The reason for that is just it's a better product for a staker, and it's extremely useful in DeFi. And DeFi, if DeFi is out to outcompete the traditional finance, using liquid staking will grow with it. So, and I believe it will.
All right. Anyone have any thoughts on this? I'm sure you do.
One small addition. I'd also agree that I think the future of ETH stake will be in pools, and that a very high amount will be staked. The one thing I will say, though, is that I think most stake will be operated by groups. I do think distributed validator technology has more upsides than downsides, and I think, even in your pools, like Lido gives 1% to one operator right now, but I think they would prefer to like spread that risk across 4 operators rather than being exposed to like losing them in like solid chunks. So I do believe that it will be in pools, but I do believe it'll be groups, not single entities running stake.
Yeah, for sure. Yeah.
And I guess on talking about distributing across pools is similar to how you can distribute stake across protocols. So I think it's important that there's not a monopoly, or it's not a winner-takes-all market in which protocol controls the most liquid staking on Ethereum. Essentially, a couple of reasons. One, there's been risks about having DAOs controlling a protocol which controls a significant share of the beacon chain. That's been widely talked about. There's also a competition element as well. Like, competition is healthy, and it's important that we are all competing against each other to better each other and also improve the health of the ecosystem. The more we compete, the more we will innovate, and the more we can improve the health of the ecosystem. So I think that's an interesting part that I think people should bear in mind.
Yeah, I think the market for staked ETH is going to, the water level will rise so much that I don't really think, I'm not that worried about competition, because I know the rise in the water level is going to be so high that that it's going to be there. So about 50%, I'm thinking, is probably more in terms of ETH staked. It's kind of like how much ETH is in long term versus short term. Short term, you want to use it for gas, although with account abstraction, you could use liquid staking token as that. So there's that sort of balance between those two things. So yeah.
Yeah. So I don't think it will look so much different regarding the distribution. I still think about 30% will still be in centralized exchanges, because it's very comfortable. A lot of people still trust them. It's very easy. Regarding the other percent, I think it will be from pools and staking services, but the market share of those will be very competitive, right? Right now we have around 14 million Ether at stake. This number is projected to grow to about 40 million, 50 million in the upcoming years. And that new Ether that will come in will not only go to the existing pools or services we have right now, right? It's starting to be a big market. And once it's a big market, there's a lot of competitiveness. And we will see a lot of different new staking pools, a lot of different niche and a lot of different user segments that are targeting, especially when you take into the fact that a lot of the DeFi will be engulfed in staking, or the other way around. So yeah, a lot more competitive, a lot more new actors.
Interesting. So I'm hearing a few different things here. One thing that I'm thinking, everybody seems to agree that liquid staking derivatives are the future for staked Ethereum, and that most staked Ethereum will somehow make its way back into liquidity again. Sounds pretty reasonable to me, especially given the growth of LSDs on chain right now.
Yeah, I just want to add a final point. it's hard to put an exact percentage on what will be staked, but ultimately it's a risk reward. So it's clear that liquid staking derivatives will be integrated in DeFi, and the utility of these derivatives tokens will continue to grow. And so it gets to the point where, unless you're paying for gas fees or doing something that's very specific to requiring ETH, it makes just complete sense to stake your ETH. You secure the network and you get to earn a yield. There is always going to be an inherent risk on any of our protocols, and it will be like in like traditional finance sense, it'll be like a risk return. How much are people willing to take on, whether it's a couple of percentage yield on their ETH, to take on the risk of owning liquid staking derivatives? So yeah, and there's a lot of capital that's going to be coming in. Like institutions is a big focus market now for a lot of people in the space. And everybody has different risk tolerances. So it'd be certainly interesting to see how things grow in the future. But yeah, again, I repeat, I fully see LSDs being the majority of what you see across DeFi at least.
Yeah. And another thing I heard from this was that you think, well, Oshin mentioned it very succinctly there, that groups will be much more aligned in the long run than individuals with the Ethereum stake. It makes sense to me as a node operator. I would want to have backups, and I want those backups to not be me because, you know, if something happens to me, I need a backup who's not me. Totally makes sense. Ariel, I noticed you were about to say something?
Yeah, also I think like the users, the stakers will be less loyal because once you can exit, there will be a lot of migration between the project, right, the competitiveness. But also with all the new technology that comes in, especially DVT, I think in the bottom line, most of the stakers will be able to sleep better at night, knowing that they have more redundancies, more backups, and more resilience infrastructure.
Great point. So speaking of the new technologies, I have another discussion question that revolves exactly around that. So other than withdrawals, which we all know are going to be the most important thing for Ethereum staking, I've been a part of a few conversations today at the fantastic Devcon event that have revolved specifically around withdrawals and how quickly we can get them out, or wait for something else or whatever. But at the end of the day, we all know withdrawals are really critical. That's the one real piece missing from the crypto economic puzzle for Ethereum staking at the moment. So you can't use that, sorry, it's not allowed as your answer. The question is, other than withdrawals, what is the most important upgrade for Ethereum staking? And so anyone can take this one. Vasily, I'll skip you here. You want to go, Darren?
Yeah, I know that Vasily and I agree, and actually Ocean as well. So there are two important upgrades that Rocket Pool and I think a lot of staking kind of pools need, and that is there's a EIP called 4788. 4788 it means that so at the moment the beacon chain the consensus layer and the execution layer are two separate things. There's the two separate concepts that don't really talk to each other. And so as a staking pool, you kind of need these semi-trusted oracles that oracle information across the two. There's EIP 4788, which puts the beacon chain state root accessible to smart contracts. That gets rid of all of that semi-trusted oracle stuff. And it actually opens up a lot of innovation for staking pools and other staking businesses. So that's that one. The other one is, so currently there's this withdrawal credential called 0x01, and that is essentially when consensus rewards are withdrawn, when you exit a validator, it goes to this 0x01 credential. And now, in staking pools, a lot of times that's a smart contract that ends up distributing it to all the parties that need that ETH, or should have access to that ETH. But and 0x01 is important because it facilitates these protocols to be able to do non-custodial staking. The unfortunate thing about 0x01 is it doesn't allow you to exit the validator. You have to rely on the node operator to do it. So in a permissionless situation where you don't, as a staking pool, we don't control the validator, the node operators. Our node operators are like 1,600 individual node operators all over the world. We have no control over them whatsoever. 0x01 enables a protocol to be able to initiate exits and that sort of thing. So they're probably the two things from our point of view, or from my point of view, that we kind of that are important for upgrades.
Getting a lot of agreement here. A lot of shaking heads, yes.
I won't even like shill DVT because I think that's obvious that I think it's an important upgrade for Ethereum staking. But yeah, I also echo, we were talking about it literally outside, is I think 4844 and the Beacon State route is super important because really the like biggest, in my eyes, security hole in all of the like liquid staking protocols so far are their oracles. And it's, yeah, really one of the last things that we need to take out to kind of decentralize. But they kind of had to be there when the chains were totally separate, and even now there is still no kind of communication. But I think I won't feel super comfortable until those oracles are mostly taken out of the liquid staking protocols. And I will, to be spicy, say that we're the only one before without an oracle.
I don't think so. No, not necessarily. I mean, I'll give you a quick background. The way I got into Ethereum staking was actually through Rocket Pool. I will give a shout out to I'll give a shout out to trading. I'm sure some of you are watching out there. That's yeah. Darren was not lying. Rocket Pool has a fantastic community. I have, of course, you know, I try to be as neutral as possible up here. I cannot shill Rocket Pool above the others. All of these staking protocols are fantastic, and if you want to stake your ETH, doing it with any of these protocols is a great idea. I will say that one of the things that I learned about Rocket Pool really early on that disappointed me is what you're talking about. This Oracle DAO concept is necessary for the running of Rocket Pool, and I was very disappointed in that since it was a centralizing factor. Now, I think that, you know, all five of your protocols are trying to do the best you can to stay as far away from centralization as possible, but you know, in order to truly get there, we're going to need, what was it, EIP 4877? 4788. Yeah.
The other one doesn't.
Oh, okay. Yet. Yes, yeah. That's up to one of you to submit. All right. Anything else on this topic?
Yeah, I want to throw a couple of curveballs. Like, these are not important, but what is going to change the landscape, like in some ways at least. One thing that comes to mind is like Ethereum plans to scale involve a lot more of traffic and a lot of more storage space for the operators, and that's going to increase the costs of running the node. So it will, like, it's not clear if it will or will not make it like less possible to stake from home, but it might. So that's something that we need to keep in mind. And the other thing that is also a curveball is restaking stuff that, like, for example, Eigenlayer is working on. Basically, when you can take your stake in Ethereum and expose it to some other protocols as a stake that can get slashed if something happens. It's not clear how much adoption it will get, how much it will be used. But if it will like be a combinatory explosion of how much risk you can take and how much rewards and which tokens, etc., which will make liquid staking over this combinatory explosion much harder, because like right now, you know, like either miss on some of the rewards or you take additional risks and you're not clear like how much of this risk and in what combination you should have, or you should take or you shouldn't. So it's going, like, if it takes off, really, it's going to make the life of protocol developers much harder.
That's a great answer. I think that if I remember correctly, someone from Eigenlayer was supposed to be here today in the audience. Anyone? No? Okay. I'm very excited about that as well. And maybe next year, once they launch or get a little further in their roadmap, we will have them as our sixth panelist. You never know. All right. So let's keep it rolling because I want to have time for audience questions. The next question here is we're going to go back to some discussions about DeFi and LSDs. If you're unfamiliar with what LSD is, it's this crazy drug that makes you see vision. I'm just kidding. Sorry. No, I mean Ethereum staking, liquid staking derivatives. Liquid staking derivatives are the encapsulation, the tokenization of staked Ethereum to make it liquid again. And you can do all sorts of crazy things in DeFi with this. You can collateralize it to make loans. You can have those loans called and lose a bunch of money. You can do all sorts of crazy things. So one of the things that I think that you know, LSDs are really changing in the world so far from what I can see is the DeFi ecosystem is starting to adopt LSDs as an ETH replacement in some ways. ETH staking has many times before been likened to treasury bonds for ETH in that they are sort of a risk-free rate for the Ethereum ecosystem. It's not entirely risk-free, but it's has that some elements of that. And so the tokenization of this, and adding that to DeFi has a lot of effects. So let's get to the question: how will liquid staking derivatives, LSDs, affect the DeFi ecosystem in the long term? So we know today adoption is rising. Do you think that this will plateau? Will it go down? Are LSDs going to replace ETH in DeFi long run? Who wants to answer this one?
Probably. So as you said, you get a decent yield on your ETH, and what we're already kind of seeing, kind of protocols, DeFi protocols, adjust slightly to the fact that these now exist. And we're going to see probably a big shift in innovation over the next kind of year to 2 years in terms of how new DeFi protocols come online to take advantage of the yield that's being generated from these, how it kind of breaks apart the principal and the yield, and how you do kind of funky stuff with that. So yeah, there's a lot, and even like liquidity platforms that start, I'm not sure, but anyway, the liquidity platforms are kind of using these liquid staking derivatives to kind of add an element of add some product value and stuff to their products, their protocols. So we're already kind of seeing that.
Yeah, I completely agree with Darren's points, and there's a few things that I think there's a few goals that we have to achieve in order for LSDs to be a net positive for DeFi. So one of them is having slashing protection inbuilt within an LSD, and DBT is going a great way towards helping with that. And we talk about validator withdrawals being key. That is one of the key risks right now with an LSD is depegging due to lack of withdrawals. But even after withdrawals, depegging events can still exist if there's a mass slashing, well, you know what I'm trying to say.
Mass slashing event. There we go. Yep.
So that's one thing that I think we all need to be cognizant of. The other thing is figuring out how to provide sustainable deep liquidity. And liquidity for probably all of us is probably the bane of our lives because it's super expensive and it's key to being a liquid staking protocol. And again, withdrawals will reduce the liquidity requirements, but we still have situations where in a black swan event like the ones we saw earlier in this year, there will be situations where you still need deep liquidity. And so, yeah, that's something which we definitely need to figure out. And the other thing is also making sure that, again, it comes down to having diversity of liquid staking derivatives. If there's one LSD that's the best, that everyone that's 90% of liquid staking within Ethereum, and it's the 90% of use across DeFi. If there is ever a hack or an exploit in that protocol, then that could be catastrophic to the ecosystem. And so again, it's another argument for having multiple LSDs integrated within DeFi to help protect some of the key systematic risks of the ecosystem.
Sweet. There's one thing that wasn't mentioned here yet, which is the kind of base rate of reward. I do think that the ETH staking reward will be a bit of a function. Why lock your Ether in Aave instead of getting staked ETH and locking that in Aave and stuff? There's no reason why people won't go for the 4%. But at the same time, how will LSDs affect DeFi? I actually think there's a good high chance, as he alluded to, that LSDs will wrecked a lot of DeFi. We saw, it's kind of calmed down the last few months, but there was a lot of, DeFi protocols looking for some product market fit, and they were like, how about you recursively leverage up your LSD derivative and gain more yield? What could go wrong?
Sounds great.
And then we saw in May there was
what did go wrong?
Yeah, what could go wrong, and we didn't really see what could go wrong. There was a lot of stuff behind the scenes that stepped in to prevent stuff going wrong. That was what went right, really, unfortunately, in May. But yeah, I think Vasily passed a comment about, I'm not sure people really hop out the gate. I'm pretty sure.
Yeah, so to answer the original question, like I will comment on that a bit later, right? To answer the original question, I think that yes, the staking derivative, like the liquid staking token, will be replacing Ether, and the reason in DeFi at least, and I think in most of CeFi as well, actually, and the reason for that is like a threefold actually. One is that with time we will have less source of yield in DeFi, like curve spring will come to an end eventually, like people will stop like selling CRV or buying CRV, or like that is going to dry up, and like overall like there will be less liquidity mining, so the staking rewards will be the most important and the largest source of yield in the ecosystem. That's one thing. The other thing is with time protocol risks goes down, because protocol becomes more proven, there are better techniques, better, more experience, etc., etc. People will trust more. Governance risk is also going down with time. The protocol ossifies itself and like defend against governance capture, etc., etc. will also have that. So risk go down. The yield becomes from staking rewards becomes more important in the ecosystem. So like there is just no reason not to use Ether. Staked Ether instead of Ether. It's a very hard thing to overcome, the most liquid token in the, like, except Bitcoin, right, in the crypto world. But it will happen on natural causes eventually. Like liquidity is very important, but it can't compete with that. That's one thing. The other, to answer the question, I was like very much terrified this last like half a year, but it turns out that like I was very much like way more pessimistic about how the how people actually. I'm sorry, my time is up.
To interrupt there, you just have. Hello. We just have 5 minutes more. That's the way to.
Okay.
Like if we want questions from the audience.
Yeah, it would be great to take some questions from the audience. So sorry, Vasily.
Can I just say?
Oh,
sorry.
I'll give you a quick. Yeah.
Can I just express the minority voice over here? Obviously, LSDs has been great, and pivotal in DeFi, especially before withdrawals are available. But there's also a lot of risks, right? There's the liquidity, the smart contracts, the depegging, and all of that. And it all comes down basically to your risk tolerance, right? ETH is king in this case. When I give my Ether to another protocol, I give him my Ether and all the associated risks that come with it. And I think the big players in the upcoming, like the near years, will still prefer to natively use Ether.
Okay. All right. Well, thanks so much, guys. We're going to move on to the audience Q&A session because we have just a very small amount of time left. So I saw you shoot up your hand real quickly right at the beginning. So.
Hi, how are you? Congrats and thank you. My name is Pablo. I'm the founder of Sensei Node, the first node operator in Latin America. We are talking with all of you. And I think something really important is not only geographical decentralization, but also less dependence on Amazon. As most of the node operators work with Amazon, we try to work with local and regional data centers. My question is, how do you distribute MEV? And yeah. Thanks.
Sure.
Yeah, I can answer that. It's very simple. The same way we do staking rewards. Like rewards are the same as staking. They go to stakers mostly. The node operators get the fee and Lido gets its fee, but 98% of rewards go to stakers.
With Rocket Pool, so obviously, as I said, 16 ETH is node operators, 16 ETH is liquid stakers, and so in terms of MEV and priority fees, it's a kind of equal split between node operators and liquid stakers, except that the node operators get their fee on the rewards, so they get 15% of the commission on the rewards. So they still get that kind of extra bit from the MEV and priority fees. That's the usual case. We've also got like a smoothing pool where this is particularly important for small node operators that are running kind of a couple of validators. The way that block proposals work is very variable, so you can have like 2 a year or 10 a year, and that hits small node operators hard. So if you join the smoothing pool, everyone pulls their proposals together, which works particularly well for MEV, because with MEV that's essentially a lottery block. You may end up with a lottery block that goes into the smoothing pool, and then basically everyone gets a share of the smoothing pool. So yeah, that's what we do.
We have time for one last question. Well, or two. One here.
I have a question about operator set. So in the two cases here, like Lido, Stakewise, more professional operators are involved. Rocket Pool, kind of a blend, honestly, of both. Would love to hear more about from Stakewise and Lido. Like, do you see a future where your pools include professional validators and at-home validators working together to achieve a common goal?
Yeah, sure. So that's what we're trying to design right now. We think that most of the stake should be managed by professional operators still, but what we want is to Lido for be a pipeline from like a home staker to professional operator. So you can kind of operate as a solo operator in Lido with small amount of stake. And if you do it well, and if you want to do it like as not as a hobby, because like honestly, most solo operators are not rational. Like they're not making a business out of it. They just do it for fun, which is great, right? But if they want to do it for their job, they should have the ability to like earn the reputation, earn the metrics required to get into the like set of big boys and grow up, because otherwise it will lead to catalyzation like 3 years tops.
And yeah, completely. So the way V3 is designed, I pointed out solo stakers as a key target market, but essentially this protocol will satisfy anybody who can run a node on V3. And one of the from discussions with commercial node operators, one of the key things for these guys is coming over to Stakewise V3 so they can provide liquid staking to their clients. And so in V3, every single node operator or group of node operators will have their own little mini staking pool, and their users can then mint the liquid staking token. So it offers liquid staking to everybody, no matter whether you're a solo staker or commercial node operator. So by proxy, we're going to end up with basically like an open marketplace of operators and groups of operators who are running various technologies who are on the stage today to compete for stake. And again, that can be solo stakers and also commercial node operators as well.
Great, thanks.
Here.
Hi. Does anyone of you dare to estimate the amount of, the percent of solo staker that the network will have in like 5 years? Can be higher than now or lower than now?
Great question.
Because LSDs are great, right? You can use your stake position as collateral, and you also average out the rewards, right? So why solo staking if there is no point of that, right? Some people will do it even for free. But yeah, what will happen in the next 5 years? More solo stakers or less solo stakers? Thanks.
Well, if Stakewise V3 works, we'll hopefully have more. As I said, the reason why, and Vasily touched on it, it's almost non-economical to be a solo staker. You do it for fun or because you're a decentralization maxi. And so our goal is to try and make it economical and let them get access to liquid staking, which they have not been able to before.
So with Rocket Pool, it is pretty much no different to being a solo staker. You have autonomy over your node. You bring collateral, so you have a stake. The only difference is you get paid more. That's the only real difference. From an Ethereum perspective and from a decentralization perspective, it's exactly the same. So yeah, that's where we come from for that.
Yeah, if I was to add to that, I think the question is there'll be a long tail of like solo stakers for sure. The question is how much stake will be on them, and that's where everyone up here is trying to figure out how can you let solo stakers like have a bit of capital in someone else's capital. You've the Rocket Pool scenario of make them bond. You've Stakewise V3 of let the people take the risk and choose like a vault for like a certain risk. And we hope that with distributed validators, you can trust small stakers as if they were an enterprise. You're like, yep, there's 4 of you guys and you're all credible and you're not one person. You guys can have 99.99% uptime. So we can, trust putting stake on you. You can't exit. You can't even get flashed. So we hope with DVT, people like, Lido, Stakewise, all of them can, throw a lot more ether onto small stakers and make it, make sense, as you said, not be just a loss-leading kind of die-hard hobby.
On our side, like how we think about it is to have a lot of solo node operators. You need to design system in a way that first does not require them to hold a bond, because most people who want to run a node, they don't have this much money. Most people don't have this much money, period, right? To run even half of Ethereum Validator lying around. So they have to be selected not on unbonded in some unbonded way. And that means, on the other hand, that you need to manage risks and you need to manage the white labels. For example, if you want a lot of solo operators in the protocol and you want to incentivize that, you need to understand that these are not the one operator and these guys in trench code, there's 100 nodes. This is essential for for protocols that mostly manage risk instead of bond. But even in bond protocol, there is a lot of folks run the rocket pool with all nodes, for example. So these are hard problems to solve, but I believe they are solvable. So.
Yeah, I just want to add up to what Austin said. Imagine if you can use DVT to pair yourself with reputable top-class operators, or even to pair yourself with your friends, which you trust, to run it. So the technology advances that will come will really reduce the barriers to do that in a still reliable way.
Sorry. Another thing Rocket Pool are doing, so currently it's 16 ETH that you need. So in our next release, it'll be 8. And then potentially in our next release, lower. So that's how you get more node operators. That's what we want, is more individual node operators, not necessarily more stake.
Great. All right. Well, unfortunately, we're out of time for new audience questions, but I promise you all 5 of these folks are going to be wandering around the conference floor after this. So if you have any questions for them or for me, we would all be very happy to chat with you throughout the rest of the day and throughout the rest of the week. Thank you so much, everybody, for coming.
Thank you.
I got it. Great job, man. Oh.
That was great. That was great.
Thank you. Ooh.
Thank you so much. This is great. Thank you. We need to talk anyway. Yes, we totally do. Sorry, speaking English?
Okay, can I eso for me? Yeah, I love that. I don't love it so much when. ¿Falta uno? No, sí. ¿Cómo van ahorita? No, que falta uno. Tú aquí me conoces. Ah, ya, uno lo tiene. No, lo tienen por allá. Ya, yeah. ¿Cuántos micrófonos tenemos? 3, son 4. 4 con el presentador.
Andrés. ¿Sigue Giorgio?
Hi. Pero ve, aquí no puedes quedarte por el frío.
¡Ah! Pero ese calor ahorita no tenía.
No, y eso que yo les dije acá, que por favor me prendieran el aire.
Y No, no lo
No, me contestaron, es que no, es que aquí el
You?
aire es natural.
Colombia. Can I? Thank you. Can I leave my bag here?
El micrófono
Huh?
encendido.
So this lighting talk, anything that you want me to tell to the audience?
Oh no, no.
¿Era ese?
Is it good? This one?
¿Era este? Los tres los tengo apagados. No, los tres los tengo apagados. Estos tres. Ay, veas el countryman.
¿Es ese?
Sí. Sí, mira, es este.
Sí, ya está la presentación.
There you go. So this is a lighting talk. It's going to be 7 minutes. And please, a big round of applause for Yorgos from Sigma.
So thank you, everyone. I'm Georgios. I do product for Sigma, and I'm going to talk to you about how bridges can improve L2 composability. So let's look at some numbers about the L2 growth. So at the moment, there are more than 20 rollups on top of Ethereum, and all the total value locked, which is a good proxy for user adoption, is like around 6 billion, which is around 1/5 of what mainnet is. So that shows like that is going quite well. And two of the most important rollups, like Arbitrum and Optimism, respectively, they have more than 160 dApps on top, right? However, there are some side effects. So all these protocols and dApps are silos across all these rollups. So the liquidity is fragmented, and the end user experience across using all these rollups is not so optimal. So it looks like there is a trade-off between low fees and high transaction throughput over composability. So what is composability? In other words, it's the money Legos. Like, it's what fueled Ethereum growth all these years. And yeah, as we can simply see here is on L1, how a yield aggregator can use a DEX, or how a lending protocol can use a standing protocol. I can build on top, right? And as you can see here, L1 is, there is composability on L1, and all these optimistic or ZK rollups, different ones, there's also composability inside them, but not across them, right? So that's the issue we just described. So as an example, these are 4 of the most popular protocols, and we see that they are deployed on Ethereum and the rollups, and at least 2 of the rollups. But all these deployments are separate from each other, right? They cannot communicate with each other. There is no connection between them. So you can see the L2 ecosystem is quite huge, quite thriving, with all these kind of apps like DEXs, yield aggregators, NFT marketplace synthetics, but it's fragmented. And here's an example use case from a user perspective, right? So a user has some liquidity on Curve, let's say on Arbitrum, and they want to move it to Optimism. To do that, they need at least 13 transactions, like wallet confirmations, and they need to wait 7 days for exiting the rollup, and of course they need to pay the exit and the entry fees, right, on mainnet. What has been the role of the bridges so far? Apart from the canonical bridges, there are at least 10 bridges for rollup hopping, or this No? Better. Okay. So we solved 2 of the problems, so you don't have to wait 7 days anymore, and you don't have to pay the enter and exit fees, but all these 13 separate transactions still exist. Right? So what we propose is, that the bridges should move away from just this ERC20 token bridging and focus more on message passing, right? So how do you pass messages from an L2 to another L2 or to L1? And yeah, the end game of that is, you can call them the cross rollup money Legos, right? So this is the same diagram we saw before, but now you can basically use a DEX on L1 to communicate with derivatives protocol on an L2, right? And all these kind of synergies over there. So yeah, the benefits of this cross rollup composability for the end user would be that they don't have to manually bridge anymore for any kind of cross rollup transaction, like a token swap or moving the liquidity, or any kind of governance actions like voting or market making or money market transactions like lending or borrowing, not having to move the collateral. Or NFT marketplaces, they can market the NFTs wherever they want, in wherever L2 they want. So how this could look like? So this is our proposal, like a cross rollup composability layer, and you can see on top is imagine like one rollup on top and another rollup below, and in the middle is the relay. So it's basically off-chain relay network. And the main concept here is that you have generic message passing smart contracts developed on deployed on both rollups, and you have the so-called adapter contract, which will prepare and parse the necessary messages, right? So this setup will help any smart contracts from one rollup to communicate with another rollup, or even with layer 1. Yeah, so that was basically it. Lightning talk. And yeah, we can have some question. I don't know how much
we have
time
one,
we have.
just one question.
Yeah, in case there is a question.
Sound here. Sonido. Sonido en el 6. Oh. Aló, aló, aló. Sonido. Sonido, sonido. Sonido, sonido en el 6.
How does the relayer maintain L1 level of security, like you mentioned?
So I didn't mention that it maintains L1 security, but yeah, there are several kind of setups, right? So you can have a fully trusted setup. You can have a trust minimized setup with kind of optimistic model or a ZK model. So yeah, I mean, if we're talking for this specific proposal we're doing, we're starting with a kind of controlled setup, and we are exploring optimistically, putting the state back on L1 or using ZK. So this is something that's still work in progress.
Thank you so much. Big round of applause for Yorgos and Sigma.
So we have our next lighting talk. So anyone wants to change room, guys, for people to fill the room? These are just like 7 minutes. So if you are interested in get to your next talk, it's time to leave the room. Whew. This has been intense, guys. Presentación. This is for you.
So, how do I? It's just back and forth.
Are you from Truffle?
Yes.
Are you from Truffle?
Yes. So is this just back and forth? That's it. That's all I need to know.
Oh. So big round of applause for Faina. Truffle.
Hi, everyone. So my name is Faina. I work at Truffle. I lead our Layer 2 tooling team. You may also know me as Bitsplaining. I write a thread every week on Twitter about what's going on in the Layer 2 ecosystem, focusing on protocol developments and educational materials. So because of the work that I do and because of the threads that I write, I feel like I'm in a very unique position to talk about the themes in the Layer 2 ecosystem and the trends that I'm seeing. So I'm hoping to give you a bit of a bird's eye view of the Layer 2 ecosystem today and what I'm seeing in the themes. So to start with off-chain data. Off-chain data in rollups is here to stay, I think it's fair to say. On the rollup level, we're seeing a push to give users a choice of off-chain data. In ZK rollups, that looks like Validiums and Volitions, and for optimistic rollups, that looks like Arbitrum Nova and MetaSTAO's optimistic data availability. Really, the question you should be asking yourself when you're considering off-chain data for your dApp is, what does this mean for security? What does it mean for my users' funds? And I think that there's a lot to consider there. If we accept that off-chain data is here to stay, then we should be thinking about ways to make those dApps more secure despite the off-chain data. Some dApps don't need all of their data on-chain, and those that might need more security, there are some solutions. One thing that I thought was really interesting was an article that actually came out today by Polinia, who's someone on Twitter that I follow. You may have heard of them, suggesting that we have split security data sharding on rollups. This is literally an idea that came out today, so as far as new trends, I expect to see some implementations of this sometime in the near future, but definitely not right now. But that should help with some of the security concerns around off-chain data and rollups. We're also going to continue to see progress and innovation on the bridging front. We just saw Georgios talk about some really interesting ideas about how we can have composability. But some of the things that I want to talk about are how popular Layer 2 bridges right now are centralized, and they keep the fees rather than sharing them with their users. That's not really a paradigm that we like in the Ethereum world. We don't really like centralized operators. We don't really like middlemen. So I'm expecting to see that paradigm being challenged. One thing that we already are seeing, Hop Protocol has announced that they're going to be more community-centric. So that's just one early example of sort of that shift that I think we're going to see. We're also seeing really interesting work around ZK proofs to improve bridge architecture. We can use ZK proofs to verify. So Suez Bridge created a proposal called the Slush proposal, doing just that. We can also use ZK proofs to create light clients with ZK snarks, which is a relatively new idea. Succinct Bridge wants to do that, so that's what you should look up if you're interested in that. So I would definitely keep an eye on ZK proofs within bridge architectures as a way to improve those architectures. And also, in case you missed it, L2Beat announced last night the release of their bridge dashboard, which is really exciting because I think the more information that we give to users about the security of the bridges that they want to use, the more we can push bridge protocols to work to increase security. And also we're giving users that data so they can make the informed decision about which bridge is right for them. When it comes to optimistic rollups, we're going to see these protocols branch out and really dive into innovative optimizations. I've called them optimistic optimizations, which I think is kind of fun. Arbitrum Nitro and Optimism Bedrock are both huge steps forward for the ecosystem. Yesterday at the Rollup Day event, Vitalik actually proposed several possible ways that we could decentralize provers and also diversify provers. And luckily for us, both Arbitrum Nitro and Optimism Bedrock are already architected in a way that should allow for multiple provers and different types of provers. One of the cool things about both Arbitrum Nitro and Optimism Bedrock is that they're sort of paving the way for allowing validity proofs within optimistic rollups, which is really cool and something I would definitely keep an eye on. Rollups with layer 3 capabilities will honestly be able to eat up a lot of the market if they get off the ground, with offerings like privacy dApps, permission dApps for institutions, games, and even creating space for alternative L1 chains to execute on top of the layer 2 and ultimately still settle on Ethereum, gaining Ethereum security. Success here will depend largely on ecosystem support, documentation, and ease of use. This is also kind of a new theme. Recursive proofs exist on Starknet now, but they're still pretty new, and I haven't seen any actual implementations of layer 3s yet. If you have, let me know. I'd love to take a look. But I do think layer 3s will be part of the discourse in the coming months and years as all of the ZK rollups especially mature and go to mainnet. Speaking of ZK rollups, ZK EVMs are likely to dominate the attention of the layer 2 space in the coming months. ZK EVMs are really exciting and something a lot of us have been talking about for the past, I don't even know how long, honestly, since layer 2 kind of became a thing. And the reason they're exciting is because they are theoretically compatible with existing Ethereum tooling, making them much easier to use. They allow for a shorter waiting time to exit, to get finality, and also because they use ZK proofs, and we all love math. Well, I do anyway. And I think as these protocols enter mainnet, the debate will turn to what counts as a true EVM. What is close enough? What is EVM compatibility, and how much of it do we need for a ZK EVM to really operate the way that we expect it to? We'll also be talking a lot more about the innovative architectures and use cases that ZK EVMs allow. So I'd say things are getting a little spicy in the cryptoverse around various ZK rollups that are entering the ecosystem. I posit that competition is good, and I hope we can turn the spice into something constructive and eventually coalesce around some helpful standards. I think we're sort of in that diverge-converge area when it comes to ZK rollups, and we're still on the diverge side, but hopefully we'll get to converge soon. And you know, we're going to see a debate about how important ZK EVMs are, and that's also going to necessarily mean a discussion of how Starknet's non-EVM ecosystem compares. We'll see more comparison materials and discussions of how security, decentralization, et cetera, compares between the two types of ZK rollup protocols. There's no question in my mind that the ZK space is red hot right now, and I expect ZK rollups to really take the stage going into 2023. If you had to pick one theme of anything that I've mentioned, it's ZK rollups and probably ZK EVMs in the near future. Oh, sorry. So it turns out 7 minutes is not very long. I'm literally being told right now my time is up. So I did create a list of some more trends to keep an eye on that I didn't really have time to dive into. I'm particularly interested in the modular blockchain designs of protocols like Celestia and how they will relate to how those learnings can be taken into the layer 2 ecosystem and maybe make changes there. So you might be thinking, how on earth can I stay on top of all of these ecosystem developments, and the space moves really quickly, and that's a valid concern. So I provided you with a list of some of the Twitter accounts that I follow that have some great educational content. I really recommend following these people. It's the best place to start, and then from there you can kind of see who they follow and what they're posting and become as educated as you want to be about the layer 2 space and how the ecosystem is growing. So in conclusion, layer 2 is here, it is changing fast, and it's bringing some of the most exciting innovations imaginable to the Ethereum ecosystem. And again, my name is Faina. Thank you all for your time. Sorry for going over time. And I hope that this talk was educational.
Woo! Thank you, Faina. Thank you so much. So guys and girls that are here, lighting talks, I know like 7 minutes, you want to stay more. So I beg you, at least 20 people, because we have a line, and we are going to sum up till 3 lighting talks. So after this is the last one, we need to clean the room up. So you can stay for one more, and to keep like the people moving.
This is next?
Yep.
All right, cool.
I will choose the thing.
What up? Good? All right, cool. Hey, what's up, guys? I'm Matt. I lead product at Arbitrum and Off-Chain Labs. This is really cool. There's lots of people here. It's really exciting. I'm actually really happy that the last 2 people covered, kind of cross-chain messaging and bridging and layer 2 stuff, because I'm going to talk a lot about that, but it's great to have context. So again, I'm Matt. Welcome to my TED Talk. So 3 things I'm going to try to cover here. There's a lot of stuff going on in layer 2. There's a lot of stuff going on in crypto. I'm going to try to focus on 3 things. Last one I know is broad. We'll talk about bridging, talk about compatibility and interop, and I'm going to talk about some scalability issues that I think we're starting to coalesce around that we have been talking about for a while. All right, so bridging, right? You got to move funds from layer 1 to layer 2. At some point, this shouldn't be something you have to think about, right? So we want it to be, we want there to be 0 degrees of separation between the layers at some point in the end game, right? You bridge right on to layer 2. So here's where we are today, the state of bridging. It continues to be really challenging. It continues to be risky. We see hacks all the time. It's not great, but it's something that we have to deal with. UX for users is tricky or even impossible depending on the asset, right? Not all tokens are ERC20s. Sometimes you can't bridge. Sometimes you have to bridge in a different way. So it becomes really challenging for someone trying to use any kind of crypto product in the beginning when you have to educate them on what bridging is. And what that means is for developers, not all token implementations are created equal. On Arbitrum, we have standard versus custom bridging. So when you're bridging an asset over for the first time, we can deploy that contract for you on layer 2 and it'll auto deploy. But yeah, if you have things like interest or other things that are maybe more custom for your implementation, you have to work with us or you have to build your own custom solution. So it's pretty complicated, and I think we're not in a space where things are perfect, but we're making a lot of progress. And kind of at a higher level view, this is our bridge, fantastic work from the team, but if you think about it, bridging is really designed for power users, right? So it's not something that in the long term we want to have be kind of like the canonical thing you have to do on the blockchain. So what's next, right? And again, this is a lightning talk. I'm trying to go as fast as I can. One thing that we're exploring is fast withdrawal confirmation. So on Arbitrum Nova, we have a data availability committee. We can actually use that system to allow for withdrawals back to L1 to take less than a week, be almost instantaneous. It's not something that's live yet, but something we're thinking about. It'll make this a lot smoother. Let's see. Yeah, something that we'd like to see happen in the ecosystem is more wallet integration, deep wallet integration, I would say, with fast bridging. So when you're in a wallet, you have an asset, you can just use a fast bridge from within there. You don't have to go on the browser and actually sort through all these options and make trade-offs with your own independent research. You can actually have that be like automated for you. Obviously, that's going to require kind of community discussion. This is just something that goes without saying. Something that we've done a lot of work on is within the bridge itself, increasing discoverability of fast bridges and making sure it's more performant, right? Not all bridges are created equal. There's lots of different options, and so doing what we can from an agnostic perspective to make sure that we provide the best UX is something that we try to do all the time. And something I'd like to see long-term is bridge aggregation as standard functionality, right? There's lots of trade-offs you have to make to find the best performance, the best security between all the options that are out there. Having functionality built in, and I talked about this with wallets before, as kind of a standard functionality where you're given a bunch of options, you can see the average cost, and you can make a decision for yourself in the UI, that would be great. And making that standard across all options would be phenomenal. So, sorry, I'm going really fast, but the next thing I want to talk about is kind of compatibility, right? So we're in a good state right now in Arbitrum on a lot of layer 2s. Drop-in compatibility is standard. So the good news is, EVM programs work out of the box. It's something that you can rely on. Moving on to layer 2 as a developer is basically kind of like not a huge issue. And the other thing is core infra that you kind of come to know and love on Ethereum, on L1, on other blockchains, RPC providers, price oracles, graphs, monitoring analytics. It's all there. It's already ready for you on L2. So we've got a robust set of tooling and infrastructure if you want to deploy. So we're in a pretty good state there. And SDKs and frameworks, we have new things like Foundry coming up every day. They're beginning to multiply. You have lots of options. You have lots of things that you can potentially use to make your development experience easier. This is just a quick graphic. With Nitro, we're running Geth at the core. So in terms of compatibility, we're reaching parity as much as we can. So what's next, right? You can keep pushing the envelope here. But one thing that we want to think about right now, contracts, solidity. As you think about rollups in the future, we want to see broader language support for smart contract execution. So this is something that you can imagine having different options to write your contract code in and compile down to something that'll still work with the EVM. It's a really exciting time. Again, right now on Arbitrum, we have two-dimensional gas. We price L1 call data posting costs separately from L2 execution costs. This is something that if you're a developer, if you're a project, you're doing a lot of things, estimating it and getting accurate pricing for the gas as time goes on, especially with high volume, is really difficult. So making that better and working with wallets to have different standards with transaction types is something that we want to push for. Again, I mentioned before, lots of these SDKs popping up. I think as more developers come into the space, and this goes on to this next point, longer term, having better rails for Web2 developers to come into the space with canonical paths forward for any kind of applications and having community consensus around what the best tooling to use is something we need to all think about. It's hard to make those trade-offs. The last point I want to make here is there's a huge perception issue in kind of like major tech. I came from that industry before working here. People are not super enthused about crypto development, and we need to do something about that. I don't know exactly what that is, but it's something that we all need to think about. So kind of a philosophical point there. I think this next point is kind of on performance, right? Like as much as we can increase throughput and bandwidth and execution speed on the chain, more people will use it, more developers will build. So the good news is this is happening all the time. We're doing this today. We're at a conference talking about how we can all work together to make this possible. So there's lots of stuff happening. We shipped Nitro a couple months ago. We 7x'd our capacity. We lowered speeds. Things are looking pretty good for rollups. And the one thing here to think about, though, is we focus on gas all the time. Remember, rollups and blockchains in general are not just about gas. You have to have security on the chain. So making performance for validators or for nodes that are serving as validators, making that more efficient, making that more accessible is something that's going to continue to be more important as time goes on, especially with stake growing in the way that it is. And this is just a quick reminder: fees are low. They're not arbitrarily low. They're not tiny, but we're getting better. Things are kind of improving. And so I'm not sure how much time I have left. Yeah. So state bloat, it's a problem. We're going to try to continually, optimize for client performance, and there are a couple things that we're experimenting with: rentable storage. We've talked a lot about statelessness. There's still a lot of work to be done here. I think we have a lot of progress to be made. The one last point I want to end with is, at a high level, in order for state bloat to be a problem, we need to get people to actually use blockchains outside of the canonical use cases we're comfortable with today. I personally would like to see a lot more use cases come to market with lower barriers to entry. Right now, most games in crypto, in order to play, you got to spend $500 on an asset. That's not something that most people can actually do, right? And you're going to make a leverage long on some asset that you've never heard of. Most people, as they go into the world and want to try to experiment with these things, you need to make sure it's easy for them to get involved with. We want to make sure things like onboarding into DeFi, having account abstraction, being able to pay with different fees for your transactions, pay with different tokens for your transactions, something that we want to see, something that we want to encourage. And something I want to talk about, just as the kind of a last point, is we have novel experimentation going on with insurance on chain. We see a lot of hacks. We see a lot of teams focusing on security, focusing on audits, focusing on having the best talent in-house to make sure that things are secure. That's not the only way to solve the problem. You can kind of think about hedging in a different way. So baking in insurance into the core flows for DeFi is something that I think there's a lot of potential and that we have lots more of experimentation to do with. So sorry for going really fast, but yeah, that's Arbitrum and that's us.
Woo!
Yeah.
Thank you for the sprint. You did it. So they're telling me that the queue is not that long, but at least we need 10 people to move to the next talk. Really appreciate it.
Yeah, we're running.
Are we a little bit off?
Yeah.
Yeah, we're 10 minutes behind.
Okay.
So I think you're first. Yeah.
please welcome to Taz and Dan. They're going to do a lightning talk, like 2 people for 7 minutes. That's a challenge, guys.
3.5 minutes each, yeah. So do we have our slides?
Slides.
Okay, great. Okay, so we're going to talk about a formal Layer 2 standards working group, which has been formed as an EEA community project managed by Oasis, and we'll explain what that means. But first, I am Tosh Dienish. I work at the Ethereum Foundation on ecosystem support, focusing on the enterprise ecosystem. So I work with the Enterprise Ethereum Alliance, chair the mainnet interest group, co-chair the EEA Community Project Governing Board, and this is Dan Shaw.
I'm Dan. I've got a decade of kind of bringing together innovators and the enterprise, help bring Node.js into the foundation, been a founder, done a lot of open source stuff, and I am the co-chair of this. And Dr. Andreas Freund is my co-chair, and with a storied background. He's the spec lead on the baseline protocol, and as well as my co-chair, as I mentioned. Okay, so last talk really teed up why standards are useful. To have a space and a clearinghouse for discussions and a neutral space, right? There's so much innovation that's happening that we need to to come together, and our perspective is in part from the needs of the enterprise, and in order to sort of continue the adoption that we're seeing, Layer 2 is essential. So putting into place those standards and specification to enable Layer 2 to thrive.
So why are we doing this as an EEA community project managed by Oasis, and what does that mean? So Oasis is a nonprofit technical standards body that was formed in 1993. They've done things like XGML and XML and a lot of sort of technical software standards, sort of along the lines of IEEE or W3C, IETF. So the Ethereum Community Projects was formed 3 years ago as an Oasis open project. So under the Oasis standards bodies umbrella. What happened to my slides? Uh-oh. Okay, there we go. By EF consensus and the EEA. So Ethereum Community Projects is it's an Oasis open project, meaning it's open source, open standards development, and so we chose Oasis because it's pretty low bureaucracy and it's a flexible standards process, unlike some of the other ones like the W3C and IETF that are a lot more sort of bureaucratic and cumbersome. Oasis is kind of more Ethereum friendly in that it's lower bureaucracy and flexible.
So some of the folks that are involved, of course, Tosh and I and Andreas from the EF. We have Accenture, Boba, Matter Labs, Metis, Off-Chain Labs, Optimism, and Polygon. And we'd love to have you, so please come and join us. Tosh?
So what have we been working on? There are lots of ideas for standards development topics in the Layer 2 ecosystem. The two that have gotten the most work done so far, first is a canonical tokenless format, which, so the issue is that most Layer 2 projects have a list of tokens that exist on their Layer 2s and a way that they map to, in many cases, a Layer 1 token or a token on another Layer 2. And these lists are not maintained in any common standard format, so standardizing the way that these token lists are stored, it would be beneficial for interoperability. Another project is address aliasing. So the goal here is to be able to deterministically derive addresses of a digital asset or an externally owned account on an EVM execution framework when it moves across chains. So if you know the origin chain of an asset, you should be able to deterministically derive the address of it on another chain. We have many ideas for potential future topics to work on. Layer 2 transaction fee structures, Layer 2 interface transaction interface standards. One idea that's gotten some discussion is about cross-chain bridging of digital assets with residuals. So the issue there is that if you have a token, like an NFT representing a bond, or something that gets royalties over time, something that gets payments over time, and you move that to another chain, it breaks the connection between the payments and the asset. So that's not a completely solved problem. There's been some discussion about that. We'd love to have more ideas on that. And if you have other ideas for topics, we'd love to hear them. We would love to have your involvement. Please get in touch.
So thanks a lot. We meet bi-weekly. You can hit us up on our emails. The GitHub is github.com EA/Oasis L2, and big thank you and shout out to L2 Beat at DevConnect. We've gotten this initiative off the ground, but thanks to L2 Beat's event at DevConnect, we were really able to get a lot of the initiatives that you just saw set up and really move forward. So we'd love to have you join us. Thanks.
Thank you so much. Guys, you did it. The two of you were the fastest ones. So once again, I know lighting talks are short by its own nature, but we have people doing a queue, so if you would like to sacrifice by the public good of letting people be here, we highly appreciate that. Let's wait a minute if people are wanting to go. Tish, I hope I'm pronouncing properly your name, sorry.
It's butchering it, but it's completely fine. It's Thijs.
Thijs.
Yeah.
Okay, so the stage is yours, 7 minutes.
Thank you. All right, so let's talk a little bit about my favorite topics, which is fiat on-ramps and layer 2s. I'm Thijs, I'm the founder and CEO of OnRamper, hence you can imagine my interest. Now, let's go through some basics. What is an on-ramp? So an on-ramper is not a party like Coinbase. Coinbase is a broker, is a wallet, is an exchange. We will define fiat on-ramp here as a third party that offers a API or a widget for wallets and exchanges so their users can then buy crypto. So that's parties like the ones you see here. There's about 12 of the biggest in the space. MoonPay probably being market leader. And each of these on-ramps is good in different things, right? You might recognize some names. Example is Great Southeast Asia. Transact does local payment methods as well. MoonPay tries really well and does really well and quite a lot in credit cards US. Now the question is, how do you judge fiat on-ramps? So there's three main components here. Number one is fees. Quite obvious, quite intuitive, won't dive too much into. Now, the second one, reach. Reach is how many countries does a fiat on-ramp support? How many fiat currencies, how many cryptocurrencies, how many payment methods? And the third one, which is sadly overlooked a lot, is success rate. A lot of fiat on-ramp transactions actually fail, so you need to have the right fiat on-ramp that will actually make a transaction work in the right region. Now, I'm from OnRamper. We are a fiat on-ramp aggregator. That means that we work with these parties, we aggregate them all, we put them all in a single API and a single widget, and then we offer that to dApps, wallets, exchanges, etc. You see the interface there. This is the widget. Now, in that, users can select amount of crypto they're buying, fiat currency, cryptocurrency, payment method. And we figure out who is actually cheapest right here. You see it's Transact, but you can see that the fees actually can differ quite a lot, right? When it comes to reach, or actually if I go back a slide, so this is choosing the on-ramp based on fees, but I just said success rate is also really important, right? So we've actually just built an intelligent routing engine that can predict the success rate with each on-ramp for a specific user in order to optimize for completion rate. yeah, then reach and really the gist of the talk here. Now, if we look at the support for Ethereum on different fiat on-ramps, then you can see immediately in on-ramper, if you type Ethereum, you will get Ethereum on different chains, right? So why is this important? Well, we just heard 2 talks ago about we need to make it easier to get to layer 2s, easier to use dApps on layer 2s. Now, one way is bridging, but we have also heard the risks thereof and the UX issues. So another way is making sure that you can actually buy it directly on layer 2. Use layer 2 with credit card, preferably. So here's the landscape. I won't dive into zero knowledge versus optimistic, because there's been enough about that already, I guess. But we see the range of layer 2s out there, and in the bottom, if you can read it, how many on-ramps actually support assets on that layer 2. So right now, the one with the most support is Polygon, which arguably layer 2 or not. And after that, Arbitrum, who we just heard from, as well as then Optimism, ZK Sync, and some of the other ones. Notably, some of these layer 2s don't even have fiat on-ramps yet, right? So for users, the only way to actually get there is buy crypto somewhere else and then bridge, which we discussed is not a great way to do it. So some conclusions then. Polygon, most popular layer 2 for on-ramps. This is in multiple metrics that we track. Obviously, as aggregator, we get a lot of data in across all of these on-ramps, across all of the people that integrate on-ramper. So they're most popular in transaction volumes, number of on-ramps, and supported assets. Because one thing is a on-ramp actually supporting the buying of assets on layer 2, but then the second question is, which assets? How many assets? And you see, even with the biggest ones, we see a very low range of assets being supported. So it's really early days. Now, it's miles better still than a year ago, but we're not there. So what then? And what is on-ramper's role within that? Now, we care about improving this, because the simple reason for that is this is usually the first thing a retail user has to do, right? And often, sadly, these transactions fail. Often, these tokens are not supported. So in any way we can help out, we want to help out. So when it's about the support of tokens, there's multiple ways that we actually do help out layer 2s and projects built on top of layer 2s. One is, obviously, we have the relationships with all of these different fiat on-ramps. So we can help in improving the support for layer 2 based assets, whether that's the more regular ones, Ethereum, USDC, etc., or more specific assets. However, that is per project, right? That's not very quick in that sense, not very scalable, because it requires our human effort to work with you together. Of course, we're willing to do that, but we've also built a better way. Now, this better way is essentially taking this concept of, hey, you still have to buy cryptocurrency with fiat first, with credit cards or local payment methods, and then you still have to bridge it. But what if we make this into a single flow? And sure, if we can buy crypto, let's say Ethereum on a main layer and then bridge it over to layer 2, then still we only have one asset. So what if you can then instantly also in the same flow merge the swap on a DEX? So that's what we've built. That is what it looks like. I see that my time is up.
You can wrap up in 30 seconds.
Right. So that's what it looks like. It's a flow that allows the user to go from fiat to any asset on layer 2 if we want to make that work, even through a bridge and a DEX transaction. Now the bridge is hidden on the back end. Here's an overview of the bridges and exchanges, DEXs, that we already support. Now, we haven't been able to aggregate all of this ourselves. This is made possible by the beautiful and great people at Li-Fi. And yeah, if there's anything that we can help you out as layer 2, as project on layer 2, as DEX on layer 2, to make buying any asset possible with cryptocurrency, then yeah, reach out at thijs@onramper.com or Twitter or Telegram.
Thank you so much, Thijs. Big round of applause. Woo!
to do.
I will show you the yellow side. That means you have 1 minute. So would you like to wrap up when I show you? Is that time up? Yeah. Go left.
Hey, man.
Let's give 30 seconds more. We are about to start. Guys, sorry, in the front, if you want to keep talking, you can continue conversation outside. Thank you so much. Dr. Yaoshi.
Yeah.
It's all yours, the stage. 7 minutes.
Yeah, thanks for everyone being late for this sort of talk. So I'm Yao Qi, the founder of Allier. So at Allier, we are basically building the runtime execution and the elastic scaling layer for Ethereum. So before we dive into like Allier, we want to know like what kind of fundamental problems we want to solve, right? So right now we know like Ethereum post-merge, and later on we will also have these proto-dank sharding, and lots of like scaling solutions will be applied like sort of on Ethereum. At the same time, we have a bunch of L1s can achieve some sort of high throughput with low latency. But at the same time, as we can see, right, for the past 2 years, there are more and more popular applications like X Infinity, DYDX, and also upcoming more and more games, which already have like millions of users and have to handle like sort of tons of million requests every day. So in that case, as you can see, right, like for the past 2 years, we encounter a lot of network congestion, gas war, even for some NFT like sort of mint. Like one example on Ethereum is this other deed like NFT mint, right? So basically people probably pay more gas fees than the mint fees. It's not just like sort of the scenario on Ethereum, but also on some highly scalable blockchains like Polygon. We had this sort of sunflower game, right? But at the same time, just like so many transactions and congested the network. Same issue to Arbitrum. Basically, we had a very successful campaign to onboard more users, but at the same time, it's just like so popular, and at the same time, the network was so congested, and then they have to pause until the Arbitrum Natural came out, so they can resume such campaign. So how we solve these kind of network congestion problems for general purpose L1s? So one like sort of thing we observe, and basically on our side we want to propose is about this application tailored L2 execution layers. That's something like when we feel like there will be some network congestion for the application, so the application probably can just spin off a dedicated layer for them to handle these transactions. And in that case, all the transactions and requests can be handled on dedicated layer, and later we can roll up all the states back to the L1s. And that's all we call, either we call this elastic layer 2 or we can call L3. So some metrics, as you can see, right, at all layer, we can really provide a very high throughput, like sort of execution environment with very low, like sort of transaction fees with very fast finality. Right now, some metrics with some updated, and basically we can achieve sub-second block time, and we, even with like tons of thousand transactions per second. Meanwhile, also support both EVM and also WASM. So there are 2 products we would like to provide. The first one is like sort of short-lived application dedicated rollup, and we call flash layers. And later on, I will just share with you why we want to have these short-lived flash layers. And meanwhile, there's a persistent rollup solutions quite similar to the other like existing optimistic rollups. The idea to have the flash layers is quite straightforward for a lot of demands and requirements from the applications. Because as we can see, right, for a lot of NFT projects, one of the biggest like sort of campaigns is the NFT mint, and also sometimes it's an airdrop. Right, for this short-lived campaign, right, typically it only lasts for a few seconds or a few minutes. In that case, they can just like sort of click a bunch of buttons via our dashboard, and protocol will automatically spin off a dedicated layer to handle the millions of requests for the NFT mint. The user can just do the NFT mint, and everything will be handled properly within a few seconds or minutes. After that, protocol will automatically roll up all the states and NFTs back to Ethereum without sort of any like third-party interaction. Like at the same time, right, apart from the NFT mint, we also want to provide very smooth user experience. In that case, there will be like sort of first come, first serve, and also a bunch of add-ons to make sure like it can relatively easy to onboard NFT projects, and also for some game projects. Beyond that, as you know, right, for a lot of games or even some derivative exchanges, they want a dedicated layer, not just for a short period of time, right? Also for a long time, for months or even years. In that case, we will have this typical optimistic rollup for it. It's just like our platform, right? The performance is quite good. At the same time, it's both EVM equivalent and also WASM compatible. Beyond that, we also have a bunch of implementation for the light clients. For example, in the future, users or developers can just run the light client or the verifiers in their browsers. In that case, they don't need to wait for the confirmation from the L2 network, so they can quickly verify the latest transaction or the latest block themselves. In that case, it can further shorten the sort of challenge period. And plus, with some hardware hardened like sort of verifiers as the challengers, so we can further like sort of really reduce the verification or even the challenge period. Beyond that, right, as we all know, there are a bunch of state-of-art and new ZK libraries, and also a bunch of game and metaverse SDKs which are not Solidity compatible. In that case, we still want to support these libraries. So we have this WASM compatibility, so we can allow the developers to deploy these libraries, and later they can use the Solidity contract to call these libraries to really have a versatile execution environment for the applications. Beyond that, right, we also did a bunch of like sort of campaigns and use cases ourselves to show up like sort of the capabilities of our layer. One that we did one of these OG badge mint like 2 months ago. We got like over 12,000 people participate in this campaign, and all the NFTs minted within 18 seconds on the dedicated like sort of flash layer, as I mentioned, right? So after the NFT minted like within minutes, so the protocol can automatically roll up the NFTs back to Ethereum. So right now, everyone can just treat the sort of NFT around floor price of 0.6 ETH or something. And another like sort of example is about game, and we hosted this like community round for Dark Forest like 3 weeks ago, and we attracted like tons of 100 players to play the game. And basically we process around 100,000 transactions per day. The feedback we got from the players that basically they didn't really notice it's a fully on-chain game. So the performance and also experience are quite good. And in that case, right, as you can see, apart from this good performance and also seamless experience, we can definitely support both NFT and also game projects. Yeah, and right now, like last week, we launched the EVM equivalent testnet, so everyone can just try out the like sort of the product for both of the systems. And beyond that, soon we will just connect to more L1s, especially the EVM compatible ones, and just try to provide a much better solution for both NFT and the game and also derivatives exchange applications. Yeah, that's sort of like all about the layer. And if you want to find more information, just feel free to DM me on Twitter. Yeah, thank you very much.
Thank you so much. Big round of applause. And we are heading to our last lightning talk. After that, we have continuous Devcon. So there's going to be drinks and food outside at the Chiba Chill Out place. So we have our next speaker on stage.
Hello.
Hello.
Is this working?
Let me check.
There's some empty seats over there if you don't want to like be there.
Yeah. One second, they're fixing the slides.
No hurries. Okay. Hello, everybody. How's it going? My name is Martin. I work at OpenZeppelin. And today we're going to be talking about data abstraction and why it's probably the future of crypto UX and probably security too. Let's begin. So let's first define what account abstraction is. And to better understand this, it's better to speak about smart accounts. You might be familiar with them already. Smart accounts are basically smart contracts that behave as accounts. They verify transactions, they hold assets, privileges, roles like owner. They can also call other contracts, which is very important. Some known examples of this is the very popular Gnosis Safe, Multisig, Argent Wallet that has social recovery, and Instant App. Now, account abstraction is basically a smart account can also pay for its own transactions. That's pretty much it. What can we do with them? Well, basically, we can have custom validation schemes. This means you can use Ethereum signatures, Bitcoin signatures, whatever signature you want, multi-signature, or any other criteria or logic you want to implement. For example, this is only valid on Wednesdays. You can implement key rotation in case, picture the scenario in which you compromise your keys. Instead of migrating all of your assets and roles and whatnot, you simply rotate the keys and you're done. You are safe. We can also have guardians, social recovery, which is a very good feature, and session keys. Think of session keys as basically, for example, a JSON web token or a set of permissions you grant, for example, a website, a web application. So you sign once a set of permissions defined by some policy or something, and then that website that can act on your behalf without you having to sign each transaction every time, which basically gives us Web 2 experience on Web 3. So how does it look today on StarkNet? This is basically the interface of an account. We are going to focus on the last four ones, which are execute, validate, validate declare, and validate deploy. We can think of this in a two-step execution flow. First, the validate step. The validate step, you can define arbitrary logic to determine whether a transaction is valid or not. There's a few limits in here. For example, you cannot read other contracts storage. This is to prevent spam. Picture the scenario in which there's many transactions that depend on the storage of another contract. That contract changes that storage and then invalidates lots of transactions. That could be a spam, so that's prohibited. So this validate function is used by sequencers to know in advance whether a transaction is valid or not, because instead of an EOA in which you simply verify the signature, you cannot do that as simply in here because you need to execute some code. And this execute step does what you would expect. Finally, since counts are contracts, you need to deploy them, and you need to pay for deployments. So how do you do this? Well, basically, we can do counterfactual deployments, which is you calculate the address of your contract before you send funds to that address that has no contract yet. Then there's this validate deploy function that the protocol uses to validate whether the funds on this address can be used to pay for this transaction or not. And then basically you deploy your smart account, well, account abstraction. And finally, in StarkNet, you can use OpenZeppelin contracts for Caro, in which we have an account, a regular account, which uses the StarkNet signature scheme. We have an ETH account, which uses Ethereum signatures, and an account library that you can use to build your own custom accounts. And I hope that by now you got the idea that it means a huge improvement in onboarding, user experience, and security. That's it.
Oh, Martin, that was fast.
Oh, sorry, one last thing. There's a pop-up for this talk. Yeah, you can just ask me right now.
Cool. I mean, since this was the last talk, you have the chance to get some questions from the audience.
Of course.
We still have
If
time.
there's any. Over there.
There you go.
So in the Ethereum version of account abstraction, you will have a separate mempool and the boundaries and stuff. So I guess in StarkNet, this role will be replaced by the sequencer itself.
I didn't get the last part.
Oh, so like in Ethereum, that in order to execute account abstraction, you need a separate mempool and a boundary system. So what would be the equivalent for StarkNet?
Right. So I mean, you mean EIP 4337.
That's right.
Right. And you're asking about the paymasters?
No, we're talking about how, like, is there an alternative mempool that actually relays like meta transactions, or how does it happen concretely on StarkNet? The use of account abstraction.
So basically, you send a transaction, and the sequencer picks that transaction, validates this validate function. If it's okay, then it's inserted into the block. I'm not sure I got the question right.
So account abstraction is actually built in.
Right, sorry. Oh, that was it. Yes, there's native account abstraction on the system. There's no EOAs. So they're completely replaced by them.
How do you ensure that in the validation process, the validation result will be the same in the actual execution?
Well, what do you mean, for example?
For example, if one transaction depends on the block timestamp,
okay, sorry. Yeah, so that's part of the limitations. So you cannot read any external information from the contract. That includes like block timestamp, other contract storage. So you cannot use anything that depends on anything else than the very same contract.
So does that mean that every wallet address on StarkNet cannot use those functions?
No, they can, but not on the validate step. They can on the execution step. But the validation step has these constraints to prevent spam.
Got it, thanks.
Yeah, so, thanks for the great talk. And one question, couldn't you just have a lot of execution code in the validate step and only at the end find out that it's not validate, not a valid transaction, and thereby spam those nodes infinitely?
Definitely. So, but there's smaller chances. So for some other reasons, you're saying that you could invalidate the transaction on the execution part, not the validation
No,
step.
I mean in the validate function, put a lot of stuff in there, complex stuff, like it takes a long time to compute, only in the end to
There's
find
a gas
out-
limit.
Okay, how much is the gas limit for the validate function?
I gotta know.
Okay, but that's the solution, yeah?
Yeah.
All right, thank you so much. This was the end of day one.
Thank you.
Don't forget to go downstairs to the Shiva Lounge, also the Hacker Basement, and thank you so much.